Hey folks, Quilly18 here, and I am super mega ultra nervous. It has been a long time since we've done some game programming content, and I've been trying to get myself doing this for about a month. The thing we're going to do today, I have recorded on my own. By the way, I got a haircut. I have recorded on my own a handful of episodes, these full tutorials 3 times now, and every time I'm like, it sucks. I want to start over and do it differently. And also, apparently, I forgot, I rebooted my computer this morning. So my camera is back on trying to automatically do video things because, I don't know. Listen, don't do the autofocus. Don't do the auto exposure. Don't do the auto white balance. Let's fix that up. That looking mostly okay, I think. At least we should get more consistent background. Yeah. So for those of you who don't know, my day job before I was a computer programmer, or before I was a YouTuber, and in fact, overlapping with that is I was a computer programmer. As part of the channel, no, this camera is way too dim. As part of the channel, I have participated in the Godot Game Jam 25 times. That's a lot of times. Do I just want to brighten it? Sure, let's just brighten it, and then I think I got to tweak the white balance some more. My apologies for not having that sorted, but I had forgotten that I had rebooted the computer, and therefore that borks all my camera settings because the Logitech driver is terrible. Anyway, 25 times I participated in that, made full games for the Godot Game Jam, and for those of you, so some of you may be watching right now, twitch.tv/Quilly18, being live streamed. Some of you may be watching on youtube.com/Quilly18 being live streamed or watching the VOD afterwards. And some of you may be watching on youtube.com/Quilly18 Crates, which is my game programming tutorial channel. Now, we used to do lots of work back in the Unity days. At some point, Unity stopped feeling fun to work with, and I'm not entirely sure why, but it was sort of the case. And then they made some terrible decisions with licensing and stuff like that, that led a lot of people like me to be like, well, let's take a look at this Godot thing finally. And I've made a few Godot tutorials, but it's been a little far in between. Over the past year, I've been refocusing my efforts on programming again for my own things, for my own efforts of doing game developments and just stuff like that, and really getting back into it and really feeling good about it. And then that's got me thinking of doing the tutorials. Part of the reason for tutorials is, first of all, they're fairly enjoyable to do. But the other thing is, I always say, and it's hardly my own quote, but the idea of if you can't explain something succinctly, apparently I can't pronounce that word, but if you can't explain something in a way that's easily understandable to other people, it's because you don't understand it enough. So part of the reason for doing these tutorials is to force myself to confirm to myself that I understand things, because if I run into any stumbling blocks during the tutorial, it probably represents a gap in my knowledge. Now, I made a video, I've been working on my own sort of multiplayer space simulation 4X kind of game. And that one technically uses Godot as a front end, but it's mostly pure C#, and I rolled my own networking in there and everything like that. And part of me was like, maybe it would be fun to do some work in Godot, learn the Godot multiplayer system and how that works. And so the whole thing is to bring us up over there. So if you are watching on any of these things, if you do want to have more conversation about this, you can join the Discord. Anyone who is a Twitch subscriber, a YouTube member on youtube.com/Quilly18. I don't have memberships turned on Quilly18 Creates, but there's also the Patreon, which will be linked down below. And if you're a member on there, you can link those accounts to Discord, and then we've got a programming channel over there. We've got channels for all the things over there, including every video game ever made, maybe. And sports, and I don't know, different things like that. The environment I'm going to be working in, just to make sure that I've got a clean environment that doesn't presuppose anything. I'm running inside of VMware over here. I've just got a relatively fresh install of Linux Mint going on. Everything we're going to be covering is absolutely 100% going to apply if you're working on Windows or Macs or Linux. Obviously, we can't tech support all those different installations. So the assumption is going to have to be that you have Godot set up. Specifically, I'm going to be working in C#, so you need the .NET version. GDScript is excellent. I also really think it's got some fantastic integration with inside the Godot editor. The script editor in there is really lovely, but I'm more comfortable working in C# for a variety of different reasons. I really appreciate the sort of robustness and the structure and things like that. We lose a little bit of like editor integration, but I think we win in a lot of other ways. So I'm going to be working in C#. So we need the .NET version to go around. I'm going to be editing in VS Code. Obviously, you can use anything you want to edit, but that's what I'm going to be set up for. And then what we're going to do is there's going to be sort of two major phases to the development here. We are going to create a little basic world, and then we're going to connect that world up in a multiplayer way and confirm that we can have two computers connecting and moving individual characters around. That's going to be the scope of what we're looking to do today. If the feedback is good, if a lot of people are into this, then what we may do is continue this in the future and add other things like go through the process of integrating some combat and things like that. That might be the next step, for example. And then we might look at transitioning from map to map and building lobby systems. And I don't know, do we integrate into Steamworks, all these things. Like, right, these are all potential future things. Right now, this is the two-phase approach that we're going to be looking at over here. So, Craigleton says, I work in C# at first with Godot, forced myself to learn GDScript and happy I did. Yeah, well, I started with GDScript. And one of the issues still with Godot 4 is if you want to do web builds, you still can't do that with C#. So there's definitely still some benefit to working with GDScript as a front thing. But my comfort level is more in C#. That's what I've worked on in different types of environments and stuff too. So it was just felt much more natural to do that. Plus, I mean, when I moved, like my Unity stuff was all C# back in the day as well too. So that's where my knowledge base is. So that's where we're going to go. But it's all going to be pretty same. Okay. What I would love to do. So a long time ago, we did a project called Project Porcupine. This was in the Unity game dev tutorial days. This was a base building game in space, kind of like RimWorld, but in space. This project went and was Sheebus. Thank you for the bits, Rio Diego. That was scary as heck. This project has since been used by several other game developers to make games that they have since published that are available on Steam. It's been really interesting when I've streamed those games and then the developer dropped in the Twitch chat and was like, hey, I started this game from Project Porcupine. That code is still up there. I mean, it's not necessarily up to date for the latest version of Unity, but this was a really fun project to work on. And this was like a 70 video series or something like that. So that, this is sort of what I want to repeat over here. And I'm tempted, I think I'm going to call this Project Echidna, which is another thing that's got a bunch of quills. The files will be placed on GitHub afterwards, and it'll be with a permissive license. I think this one was with the MIT license when we did it. I might do the same sort of thing, so that, again, you can use that code and do what you will with it. So we will see. Now, we are going to need some art assets to get started here, and I do not have the skills of an artist, and certainly we don't want to sit around doing a bunch of drawing, so we're going to need an asset pack that we can all use. I'd strongly considered using this 1-bit pack from Kenny. Kenny is a god when it comes to game programming resources. He's got they, I suppose, have so many different, because I don't know who they are, different assets available to you if you want to get started in game dev. They're all like Creative Commons, really nice to work with, and they're lovely. And what I like about this 1-bit pack is it's got this like super retro kind of Game Boy era aesthetic. Some of the colors are more like kind of almost CGA color palette, although there's a monochrome color set in here as well, which you can then tint in different ways. And I thought, okay, this might be really cool to work with. But one of the great things about this pack is all the visuals, all the tiles in here are very simple, and they're not animated as well. And I thought, okay, what if I go and find a different art pack that's got a little bit of complexity, a little bit of gotchas in there, so that we can look at those issues. So I went around and went to itch.io. Do you say itch.io or itch.io? What do you prefer? I always say itch.io. But this wonderful art pack by Anno Kalisa here, this pixel crawler set, which actually comes in a variety of different subpacks. They've got a ton of extra little subpacks for all these different environments and stuff like this. And a bunch of them are paid, and I bought the entire bundle from this because I think it's wonderful. But there is this basic starter one. Well, basic. It comes with so much crap in it. Look at all this stuff. This is all stuff that exists in this completely free pack over here. There should already be a link in the What Game on Twitch and in the description on YouTube if you want to go and download this yourself. We're only using a tiny bit of the graphics that are in here. But one thing that's interesting is both this 1-bit pack from Kenny and this pixel crawler pack are both 16 by 16 pixel tiles. And it just shows you the range of art that you can do. Now, one of the reasons I'm using this one is because several of the images in here span multiple tiles. And that leads to certain questions about, hey, how do you make that work? What would you do with that? So anyway, I'm going to be going ahead and using this. Again, I'm only going to be using one really for environment, but I'm temporarily going to use a second one from the environment to demonstrate a couple of potential gotchas. And then we're going to be using 2 animated sprite strips for our character motion. And that's it. So we're keeping it fairly bare over here for things. Anyway, so I've got to get that set up. This is the plan for today. Again, we're going to start with the basic world. We're going to talk about how to use the tile mapping system in Godot. If you're watching this on YouTube later, I'll try to have timestamps so you can skip ahead these sections. Like if you already know how tile mapping works, you could skip that. If you're comfortable setting up a basic, character body 2D with some movement and a little bit of animation, you can skip ahead there if you just want to get to the multiplayer phase. But I want to show sort of the complete setup over here rather than start with some stuff already in place. Anyway, we're gonna go and create a new project, and I'll call this Project Echidna. I think is how it's spelled, and I want to go and store it in programming / whatever here. Okay. For the renderer, we're actually not going to be doing anything fancy. We could absolutely just working in the compatibility renderer, but I'll leave it on the default of forward. Plus, we want the Git files because I'm going to be using that to manage the project, and we're going to go ahead and hit create over here. You upload this to your gaming channel or a different one. So this is also being streamed over on youtube.com/Quillyteen, the gaming channel, and the VODs will be available there, but I will be uploading it to the Quillyteen Creates channel. So, okay. Inside the editor here, one of the things I do want to point out, and I didn't realize this for a very long time, let's say you're working exclusively in 2D, and the fact that these 3D buttons are here all the time, that might be annoying, and you're trying to add node, and it's always coming up with showing you the 3D nodes, you can actually filter that stuff out if you want. If you go to Editor, and you go to Manage Editor Features, you could create a new profile. I don't have one here, but you could create a new profile, say like called 2D, and don't typo. There you go. And then you could do things like turn off, so look at this, the 3D, boop. Oh, boop. There it is. None of that. If you're not using the script editor or the asset store, you can go and turn all that stuff off. And then in the nodes over here, you can go and find the 3D node category and just turn that off and simplify your life a lot. I'm not going to do that. I'm just going to, let me just remove that, not use any profiles for that. But that is a nice way to clean things up. One of the things I do strongly recommend, though, in editor and editor settings, because I'm going to be using Visual Studio Code, you probably want to go and link that editor there. And to do that, you do need advanced settings turned on. So if it's off, we won't find an option down here for .NET stuff. If we have it on, then there's this .NET category, and you can set the editor and say that you want to use Visual Studio Code. Depending on how you have it installed on your particular machine, you might have to give it a path or something to find it, but it just worked out for me, so that's good. The other thing you want to do, depending on how you want to configure things, you're either going to have to configure a couple of settings in VS Studio Code or here in Godot, because when Godot creates files, its default is to, like code files, script files, its default is to use tabs for indents, where in Visual Studio Code, its default is to use spaces for indent. Now, if you open a file that has tab indents, that was maybe created in Godot, and you open it in VS Code will notice that and will continue to work with tabs in that file. But then if you go and create a file inside of VS Code itself, it will default to space indentation. And listen, we're not going to get into the religious warfare of tabs versus spaces for indents, but I think we can all agree that you don't want both in the same project. So you'll want to do a little bit of adjustment one place or another. I've chosen to stick with spaces. So over in text editor here, there is, and I can't remember what categories, and we can just search for it, which is probably what I should do. It's probably under behavior. Yeah, there it is. Indent over here. You see where it says type tabs? I'm going to change that to spaces. That way, when Godot bakes creates a new script file for us, it's going to use spaces for the indents instead, which will just match everything. And what's funny is that despite the fact that it creates tabs for indents, because that is its GD script style, Godot's own page on C# style, like their own style guide for C#, talks about using spaces for indents, because that is compatible with the Microsoft style guide, which is generally what we're going to want to work with. So, just a little bit of bookkeeping over here. So we'll do that. Michael Souza. Actually, I'm not sure where I should put your space as your name, but thank you very much. Your old Unity tutorials inspired me to get into the game dev. Now I've spent 2 years making chair defense in Godot. Nice! I find Godot so enjoyable to work in. Anyway, I think that's all the initial bookkeeping that I want to do. So the next thing I'm going to do is I'm going to bring in some assets for us to work with. So one of the things when organizing any project, a lot of times the default that people start with for organizing the project is they'll make one folder for maybe assets, then they'll make another folder for their scripts, and then they'll make another one for, I don't know, maybe scenes. If you're coming from Unity, you'd call it prefabs, but in Godot, scenes, Unity has scenes and prefabs. And if you can tell me logically why there's a difference between those two things, one of the things I loved when I switched over to Godot, they're all called scenes, but that's it. Everything is a scene. What we would call, if you're coming from the Unity world and you think of a prefab, in Godot, they're just scenes because there's no good reason. It's just a container with some game objects or nodes, right? Game objects in Unity, nodes in Godot, in some sort of tree structure. And why is there a difference between the two? There's a bunch of stuff that there's certain mentality I had when I'd work in Unity that is just the way it works in Godot. And I think that's one of the reasons I like it so much. Anyway, so you'd have, maybe you'd have a scene folder and stuff like this. Obviously for a small project, organization doesn't matter. We could just use a single folder and have everything in the same place. It's not a big deal. But I would like to make a case at this point that one thing that might be good as an organization is what a lot of people tend to move towards later on is instead of dividing things by file type, divide things based on area of concern. So instead of having assets, scripts, and scenes, maybe what we'll have is something like level, and then we'll have something for characters. And then within that, within level is I might have assets, and then I might have scripts. Sometimes, as your project grows, you might find this a lot more useful. Anyway, let's bring some assets in here. So from my assets folder, I want to grab in entities, in tile sets, I want to grab, and I could import the entire folder over here, but we only need a tiny fraction of what's in here. So I want dungeon tiles. And I'm also going to go and from props, static, trees, this is just going to be a temporary thing to showcase some gotchas. We're not actually going to use this for anything other than here's a potential problem you run into and how we might fix it. But I'm going to grab this size 2 file from this. So this is just the Anna Kalisa pixel art asset pack, which is really great. And then we'll be doing stuff with characters later, but for now, we're just going to work on the environment because phase 1.1 specifically is learning about the 2D tile map system. So we're going to need a scene to get started. It is going to be a 2D scene, so we're going to do that. And I'm going to call this scene, this base node, this is going to be called Lobby Town. And I'm going to save the scene as lobbytown.scene. It's going to be level. And you know what? I'll just leave the scene in the base over here rather than make a scene subfolder. That's going to be fine. So I'm calling it Lobby Town because ultimately this is going to serve as a multiplayer lobby. In a lot of games, your multiplayer lobby is basically just a UI thing, right? Where you see who's joined in, people can ready up or whatever. But in some games, like Among Us is a good example, the lobby of the game is itself a little place where you can already run around, right? If you're set in this little room, I guess it's a shuttle in Among Us, and you can interact with the one computer that lets you change your style, and the host can interact with something that lets them change some game rules and stuff like that. And I'm going to borrow that a concept over here because that way, as soon as we have one of our players join, they'll be in an environment where we can move around. So we don't have to do a 2-stage progress. We're just going to use that over here. Have Lobby Town. Great. Now, to make this look pretty, we're going to have to add some visuals, and we're going to be adding a tile map. Now, if you look for a tile map node in Godot, now, I'm assuming, by the way, throughout this tutorial, that you've at least played around with Godot here before. You know how to add a new node to a scene. A lot of times I will do Control-A for this. You can also hit the plus here. Actually, what I'll do a lot of times is I'll right-click because I'm always worried that I'm going to be adding the node in the wrong place. So I'll right-click the actual parent and go Add Child Node over here. And so we'd want to add a tile map. And so, there is a node in this in the entire node library called tile map, but it's got a little red marker over here that says it's deprecated, and the description over here says it's deprecated, and you choose tile map layer instead. Now, this is relatively new. It's been a couple of versions at this point that this has been the case. If you find other tutorials online that are guiding you through the tile map system, and you're like, oh, but now I have to use tile map layer, they are virtually the same. In fact, I think like 99% of how they work is exactly the same. The difference is with the tile map, if you had multiple layers in the tile map, and we'll get to this example soon. Play with one layer for the floor, one for walls, one for other props, one for clouds that are floating above, or different things like that. Those would all be managed within a single tile map object. With tile map layer, each layer is going to show up as a distinct node in your tree. It feels a lot nicer to organize, a little less fiddly. I don't know if there are any performance wins or anything like that. Like, I don't know behind the scenes the decision for why to do this, but it sure as heck feels a lot better to work with, in my opinion. So anyway, we're going to create this tile map layer, and it is going to be our tile map. And we can't do anything with it yet, because what we need to do with this tile map, we then have to add a tile set. So we're going to have to conceptually think about what the different terminology of things are here. The tile map layer, we can think of as our canvas. It's what we're going to be painting our world into. And the tile set is going to be our paint palette. You know, the palette you hold in your hand that's got all your paint on it, you dab at it with the brush, and you apply that to the canvas. So the canvas is the tile map layer. The tile set is the palette. The source of the paint, those are your image assets. There's sort of 3 different levels to kind of think about over here. So that's what we got. Anyway, tile map layer over here. And we have to go and create a tile set. So there's a number. I mean, in programming, there's always multiple different ways to do things, and Godot is the same way. But we need this tile set resource over here in the inspector. And what we can do is you can create an ad hoc one. So let's say we go to this pull down, we say new tile set. Now, this tile map layer has a tile set associated to it. Now, this is a resource that is just ad hoc connected to this object. It exists just in this sort of inspector link and nowhere else in the project. The other way to create a tile set, so I'm going to go and clear this. The other way to create a tile set is over in your file system view. If you right click and choose create new resource, one of the resources that you can create is a tile set. This is exactly the same. What I've just done here with tile set, and I'm going to create this, I'll just leave it called new tile set for a second. This is now a resource that exists in our file system, and I can go and link that over here by just dragging this over or using the search function in here and do that. Right now, tile map layer is exactly where it was when we created the ad hoc one. The difference is the tile set lives in our project and can be reused. We could have multiple tile sets or multiple tile maps that refer to the same tile set. And depending on what you're doing for, often, usually this is what I want, because I get sort of like screwed when I've created something and I put all this work into something like a tile set and it's not actually saved in my project, and then I can't find it or I want to preserve it or whatever. Now, if you don't do this ahead of time, that's fine. If I go ahead and delete this, and then tile map layer, that's interesting. It still has the old reference. I didn't realize it would do that. But if you went and made this ad hoc tile set over here, and then you realize you do want to reuse it, you do want it to be part of your system, from this, you can go save as, and then you can just save it into your file. So what I'm going to call this is I'm going to call this the dungeon tile set. Bum, 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 bum. Because, I don't know, we might have tile sets for outside, we might have different things. Now, we still can't do anything yet. And the reason is we haven't given this palette any paint. So, and to do that, we need to add a tile source. Now, one of the things that's a little confusing with the UI in Godot is when you select something like tile map layer, there's different modes you can be in, and that's determined by these tabs at the bottom of the screen. I don't think my head's covering anything important. Eh? Let me know if at any point my head is covering anything important. Down here at the bottom, this is in tile map mode. This is where you'd actually be painting on your canvas. If you want to manipulate the palette that you're working with, you have to click this tile set button over here. This will let you edit the tile set itself. Now, one of the advantages to having it in your project on the side here is you can also double click on this, and then you'd be editing the properties of the tile set itself. This screen here can also be accessed from tile map layer. It's not obvious, but whenever you have a resource like this on an object, on a node, you can click in here to expand it. This view here is the exact same thing as if we double click on our tile set. We get the same information here. Now, if you don't have it saved as a resource, obviously there's no way to click on it in the file system, at which point the only way to do it would be to come over here and to click on this to expand it. Now, there's a few different settings over here. There's the tile shape. We're going to be working with square tiles, but you can, if you want to work with isometrics, those are the ones that are rotated 45 degrees. That's an isometric tile set. And you can do hexagons. I'm actually not sure what half offset squares are. Someone in chat wants to tell people what they are. Go ahead, but I'm not sure. But yeah, you can do hex maps and everything over here, but we're just going to work with square tiles. You can also specify the tile size here. Now, what's interesting is this tile size is the tile size as they appear in the tile map layer. Your tile sets can have images that have arbitrarily different sizes for different reasons as well. Although in the examples we'll get to shortly, even if those images you're using are very large, they still just exist in one logical tile in the tile map layer of here. Anyway, set this to the natural size of your tiles from image source. We're going to be working with 16 by 16 pixel tiles, so it's very convenient that this is set exactly where we want it. We're going to be coming back into a few of these things later on, but for now we can just go and hide it. So, okay, great. So we've got that. We've got a tile map, but again, we need some paint over here. So we're going to add a new tile source. So in our tile set, we're going to add a new tile source, and we are going to use our images. So this dungeon tiles, we can just drag it in. You can also get to it from the plus. But if I just drop it in, we're going to say, hey, this tile atlas textures was modified. Would you like to automatically create tiles in the atlas? We're going to say yes. We're not always going to say yes. We're going to say yes here. And what does this actually do? Well, you may have noticed when I hit yes, all these little yellow lines showed up over here. And what this did is it assumed that our tile size is 16 by 16. And you can actually set that over here, right? Because this tile set has a certain size, but then there's also here the texture regions that you can set up and different things like that. But it says, okay, we're working with 16 by 16 pixels. So let's just divide up this one image into a bunch of 16 by 16 elements. And these are going to be our different paints that we're going to be interacting with. We can zoom in over here and take a little bit of a look at this lovely, gorgeous tile set that we've got. Now that we've got that in here, we can start painting that into our world, right? Onto our tile map layer. You might think, oh, I probably do this from this paint thing. No. This is the one thing. This paint button is, I understand what they're going for with this, but it is super misleading the first time around. What we want to do to paint into our world, and we're going to be interacting with this stuff a bunch shortly. But if we want to actually interact and put stuff into our world, what we want to do is we don't want to be on the tile set mode. We want to be on tile map mode. And then with tile map mode, we still see our tile set over here. And we can see that we can mouse over and select various things. And we're like, I'm going to take this floor tile and I'm just going to drag it into the world. There we go. And now I'm painting onto my tile map and I can go all over the place. I'm in pencil mode currently. We also have line mode. We've also got rectangle mode. We've got a bucket fill, which I guess if I made sure to block off an area and use the bucket, I can do that. You've got the eraser tool. Now the eraser tool is not an alternative to these previous modes. It still uses this. So let's say with eraser toggled on, if I go to rectangle, now I can erase in a rectangle. I can erase a line, I can erase in a pencil, and it's constantly going to be like forgetting to toggle the eraser on and off depending on what you're trying to do. All right, but we can go and I can be like, listen, all this floor is a big mess. Let's go and start over. So I will go and I will draw out a rectangle of floor for our world to go in. Cool. Okay. That seems pretty straightforward. Let's look at walls. Okay. So these are some walls over here. But again, this tile set, what's interesting is the art for it. A lot of it is multiple tiles tall. We're like, okay, if I want to draw this back wall, then I guess I could go and I could draw out this bottom part. Okay. And then I can draw out the middle part and then I can draw out the top part. Again, if you're coming for the multiplayer, if you're watching this on YouTube, there'll be some references where you can skip ahead over here. But I thought I'd cover some basic tile map stuff while we're here. Okay, so we can draw these one at a time, but obviously that's super tedious. Can we do a little bit better? Yeah, one of the things we can do is we can select multiple tiles at once. I can click and drag, or I can hold Shift and select multiple tiles at once. And then with that, I can go and plop down multiple tiles at a time. Oh, that's very convenient. Excellent. And then it's like, okay, well, what about our doors? Okay, well, I guess it's the same thing. I can drag out this and then I can drop these 6 tiles in here. One question you might be asking yourself at this point is, do I logically want to be interacting with 6 unique tiles for a door, or say 3 unique tiles for these wall segments? Would it be more convenient to work in another way? Well, luckily, there are different ways to go about this. Let's bring this back up and let's go back to our tile set. So let's modify our little painter's palette over here. And instead of having this wall be represented by 3 different tiles, what I'm going to do is I'm going to delete these. So actually I have to be in select mode over here. This top tile, I'm going to delete it. And this middle tile, I'm going to delete it. This bottom tile, I'm going to take it and make it bigger. So this is a single tile that happens to be extra big. Now, we're going to go and drop this into our game world. So I'm going to go back to the tile map mode so that it can draw. And notice now, if I mouse over this, this is all one selection. So I'm going to select this. I'm still in pencil mode. And then I'm going to go off to this area over here and drop it down. Cool. Okay. Now, notice it is being applied wherever my mouse is. In the square my mouse is, that is the middle of the wall. Okay, but sure, fine. Okay. What happens when I put it on one of these surfaces? Well, it's going to look, and this is broken because I deleted some tiles, but that's fine. If I click over here, I'm only getting part of the wall. Why is that? Well, the reason is, despite the fact that this tile that I'm pasting down is 3 tiles tall visually, right? It only lives in the center tile. The graphic overflows into the other 2, but it only exists in the center tile. And one way that's quite obvious about this is, let's say I went over here and grabbed this floor tile. And obviously I can draw it here. That's fine. I can draw it here. If I click right over here, what's going to happen? Well, it looks like nothing happens, except it actually has, because let's say I go and erase this wall tile. You can see that floor was behind. Now, the same thing happens if I go and draw this floor tile. So again, behind, we don't see it because the wall is covering it. But if I put it here, this is going there because everything is being drawn from top to bottom. So everything gets drawn from the top level and then down, and then overwrites what's behind it. Now, it's actually slightly fuzzier than this, as we'll see in a bit when we get to my tree example. I mean, a tree doesn't really belong in the dungeon, but it's a convenient tile to showcase that. So there's a couple of different things to consider. First of all, this obviously feels kind of bad. And maybe what I'd like to do is when I'm painting my walls, let me go and blank out the screen again here so that we've got some fresh territory to work with. Maybe I would feel better when I'm drawing my wall, instead of dropping it and having it attached to the mouse here, maybe I want the origin of the wall to be the bottom part. Because this might be our first attempt to fixing this, like some of this weird floor stuff, right? Okay, well, let's see. If I go back into my tile set, and I go over here, and we switch over to this paint properties, right? Tile set paint properties. Again, this is not how you paint stuff into your scene, but you can, instead what you're doing is you're painting properties onto your tile set. I understand what they're going for. Is it the most intuitive way to explain things? I don't know. Once you figured it out one time, then you're okay. Anyway, what we're going to do is we're going to paint a new property, which is going to be the Y sort origin. So this is going to be the origin at which the tiles are Y sorted. So Y sorted in the Y direction, right? Right now, the thing close to the top, the 0Y gets painted first, and then the thing 1 down below at Y equals 1 then gets painted next. And that may paint over something we've seen before. If we change this origin of this object down to the bottom, we'll get a behavior that, first of all, is a little closer to maybe what we want, depending on what game you're making. Again, we'll have a million caveats as we go here. I would like to move this control point over here. Annoyingly, actually, is it this or I guess actually texture origin. Hold on. Texture origin is actually what I want to mess around here for various reasons. I'm going to take this and I'm going to go and set a texture origin of 16. Apparently I don't have numlock on. There we go. Texture origin of 16. And then I'm going to paint it onto this tile. Boom. Now the origin of the tile is down here. Now, if I change this, nothing is happening to my tile because this is not editing a selection. This is setting the ability to paint a particular property. So now with this set here, if I click again, then the origin will be moved. Well, I don't want it there. I definitely want it over here. Anyway, the upshot of this is that now when we paint, our mouse, notice that the place where the wall graphic is anchored is at the bottom. Now, if I click, we get a similar situation to before. But remember, what's happening here is this wall texture lives in this square. It doesn't live here or here. And we can confirm that again. If we're taking our floor and we paint behind the wall, it does not overwriting anything. But if I went and deleted this wall, that floor would be there. Now, is that what you want? It depends on your game. Because in some games, you might, because right now, if you were programmatically querying this tile here, and you want to know what is in this tile, what is the answer? Well, right now, it would tell you it's this floor over here. Is that what you want? Maybe. Depends on what kind of game you're making. Because maybe what you want instead is 3 distinct tiles like what we had here, right? These are 3 distinct wall tiles. This is wall top, wall middle, wall bottom. That's a decision one. Anyway, I'm gonna go with this and let me paint a little pretty scene to work in. So I'm gonna go and I'm just gonna fill in a bunch of floor like so to work in. And then we're gonna start drawing this wall. And wall drawing, and that's great. And I'm going to put up this little back wall section over here. Okay, let's make it a little bit more interesting. Let's use, this little wall offset bit. This looks really good. Let's make use of this thing, and let's do the same pattern that I'm using for this one, where what I'm going to do is I'm going to go into select, and this time I'm going to delete these top three. Instead of taking this bottom one and dragging it, I'm going to recreate it to show how you can do that as well. If I delete that, I have no tiles over here to work with, but I can right click, create a new tile, and I'm right back to where I was, and I can go and drag that up. And then I'm going to paint. Now, when you're paint mode, you do get a little eyedropper. So what I can do with texture origin, I can eyedropper, say, this one to make sure to copy its settings. Or I can eyedropper this one to copy its settings, right? And I can do that. Now, 16 is not quite going to work. If I paint that here, that's not in the right position. I'm going to want to offset it by 24 instead. There we go. Okay, that looks pretty good. Now I'm going to go and paint this into my scene. I'm going to put this right here. I want that to look really nice as a little bit of an offset. Actually, let me go and come back. I'm going to do the door. I'm going to be lazy, well, lazy-ish. And I'm going to put the door as 1. Okay, that looks pretty nice. Actually, before I get back to my fancy little wall bit over here, let me go and make a full room. So I'm going to use these sections here to draw the outside of the room. And then I'm going to do this bit. And then a wall top is kind of going to look like this. Excellent for the other side here. That's lovely. And I'm going to use these little corner pieces. I'm just drawing something real quick. All right, we're going to have this beautiful scene, and then we're going to ruin it. Do this, do that, do this, do that, do this, do that. Okay, great. Lovely little room. We want to trim the floor out. I'm going to be doing something else to the floor very soon, so I'm going to worry about cleaning up the rest of the floor afterwards. But yeah, now with these fun little sticky outy bits to make our room look a little prettier. Cool. I'm going to put it here. Well, that doesn't look very good, does it? What's going on? Well, this is our graphic for this little sticky outy wall bit. That's very technical terminology, by the way. And it is very, very nicely like empty and transparent at the bottom. That's cool. But it's not showing anything back there. It's just the gray background of our world, the fog of the default thing. We lost the floor tile, and I can't put both in the same place, right? I want floor there, right? But I can't do that. Now, if I was working with a different offset, we could still do a little bit of shenanigans, right? If I go back to the tile set over here, and I say, okay, I'm going to do something thinking it's a clever fix. If I change this to an origin of 8 like this, now if I go back in the tile map, I can paint it, and there we go. Oh no, it still doesn't work because now the floor is over right in that bottom bit. So we still don't see that transparent area. What are we going to do? Well, this is where we're going to use multiple tile layers for this. So first of all, let me go and fix this tile set here because I really do want it to be a 24, and I want to paint it over here. Okay. By the way, if you've never watched one of my programming videos, this is very much my style. We do a thing, show why it doesn't work, and then look for a solution. So the solution here is to use multiple layers. The whole reason this is called tile map layer is because this works a lot better with multiple layers. Let me go and let's start. Well, no, I don't want to redraw all this stuff. But what I do want to do is get rid of the floor. You know what? I will redraw all this stuff. We're going to do it right and make sure we've got no little stray bits left over. So I'm going to do this, and I'm going to duplicate this tile map. Boom. I'm going to call this first one ground or floor or something like that. And I'll call this one, I don't know, walls. We might have more than just wall. I guess it's more like dungeon structure. I don't know, like walls and doors and shit. Yeah, it's going to be the collision layer. Crit C, excellent way. This could be collision layer. Call it what you'd like. Anyway, we're going to do these as separate layers. And what we're going to do, this ground layer, all I'm going to do is draw a big old square of the flooring. Oh, see, I'm in eraser mode. Very easy to forget that's. All right, we got that. Now, if I go back to my dungeon structure layer, it sort of grays out that level. And then if I start painting my walls, what's interesting to note here is that like the only thing that exists on dungeon structure right now is a single tile right here. Again, the graphic overlaps visually, but it only exists in this one tile. And this is going to be particularly important. I cannot draw on a straight line, la, 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 la. There we go. This is going to be particularly important when we go and try to put this back down, because when I do this now we can transparently see, and it'll be a little easier if I click off here, we can transparently see the floor that's underneath this layer. Ooh, already prettier. You know what would make it a lot prettier? if our graphics are in our smeary over here. So the graphics are smeary because, no, not here. Rendering textures. Under our project settings, our rendering and textures, we have default texture filter we can put here. Now, we could override this per texture, but this will be very convenient to do this project-wise. And this is set by default to linear. This is really good for a lot of work where you're working with higher resolution stuff that's photorealistic, things that are like textures for 3D games and stuff like that, where you actually do want to smoothly blend your pixels from one to another. There's lots of use cases where you want to smoothly blend your pixels. However, when you're working with lower resolution pixel art like this, with like 16 by 16 tiles, you generally want your pixels to be sharp, in which case change your texture filtering to nearest. So pretty. Excellent. There you go. So we're going to want that. Anyway, let's get back to drawing our pretty little thing. Let me go and smack a door back in here. Here, I'll give it a little bit more space that way. And then we'll put another one of these guys in here. Great. And then how much wall? Do I just want the 4? Sure. You know what? We'll do that. We'll go 4 this way. And then I'll go and redraw my little limits here. So we've got this, which I guess actually I was going to there. And then on the bottom, I was doing things this way. And then over here to here to here. You know, obviously this part isn't important to make things work right now, but isn't it lovelier to work in a little environment, even if it's just prototype images, which that's one of the things these like free images are good for, is to do the initial prototyping of your project. It just looks a little bit better. Okay, so we've got that. I'm going to go back to the ground layer and I'm just going to trim the extra flooring tile that we don't need. So I don't need any of those, and I don't need any of those, or that, or that. But then if we look, excellent. Okay, great. Let's do one more example of something that can go very wrong and not how we want it. In our tile set, I'm going to add another series of images. This size 2, this is a bunch of trees. I put it in here. This time I'm going to say, don't automatically create the tiles. And all it did is it didn't auto chop up this image. I'm going to take this tree here and not do it that way. Oh. I didn't realize in setup, you could just click and drag to create tiles. That's interesting. Okay, but I'm going to take this one tree and I'm going to do this to drag it. And we're going to drop this into a scene. And actually, I kind of meant to do this while we still had the flooring because it would have been way more broken. You know what? I'll put it on the ground layer just because this is going to really showcase some broken stuff that you're like, the first time you go and do this in your game, you're going to be like, oh, this is not what I want. I'm going to take this tree and I want to have it right here. Again, very much no good, not right. Right? And you're like, okay, well, the first thing I might want to do is I might want to go and in my tile set is, oh, I should change the origin because we've done that once and that sort of fixed things, right? So if I'm going to paint and texture origin, good, we're going to do that. And then it becomes kind of an interesting question of where should the origin of this particular tile be? You know, what you can do is we could decide to say, all right, maybe, oh, 8. Yeah, maybe the bottom right corner or bottom left corner should be the origin. These are possible things. Or for this tree, maybe you'd be like, actually, I kind of do want to just have it be in the middle. So that way, when I plop it on a tile, it's growing out of that middle tile, which is kind of good. Or even, you might even be like, here, I might be like, hey, if I offset it by 32 and do this, now the origin is right here. You don't see the origin preview, but now it's growing out of the middle of a tile. That's nice. What's still going on over here? Well, so first of all, we're going to need a separate layer for the trees, but let's assume we're not going to do that right away. How do we deal with this? Because this is something you're going to run into different things. Because I said the tiles get drawn from top to bottom. That's not strictly true. They get drawn top left through to right, the next one through to right, and so on and so forth. So what's happening here is, remember, this tree is currently living on the ground layer, which is where all the flooring is. So it exists in this tile. Now, this is being drawn after all these floor tiles, so it's on top. But these tiles get drawn afterwards. Man, it's weird. Anyway, what we do to fix this, with whichever object we're talking about selected, under, so with that selected, over in Canvas items, under ordering, there's an option for Y sort enabled. We turn that on. Now it's strictly going to be top to bottom sorting. No weird left and right sorting. Now, obviously, this still doesn't fix the problem because we don't want the tree growing out of the ground and blah, 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 blah. And in fact, it becomes even more so. Let's say I'm like, okay, you know what? Yeah, this was dumb. What am I doing putting a tree on this floor, right? This is the ground layer. This is not where the tree should be. But notice you can have more than one tile source in your same tile set, and you can switch back and forth. That's really convenient. Okay, put that back to a floor. Be like, right, this should be on the dungeon structures layer. Obviously. Is it though? Let's find our tree again. And so we put it down here, and it looks fine. Sure, that looks good. We put it up here. Right, that's still, yeah, that's, oh. Here, we're not seeing enough of our tree. Here, we're seeing too much of our tree. And again, the answer would be on dungeon structure. We're going to go and set the ordering, Y sort enabled. That's pretty good. Okay, I like that. And then the thing that comes down is, it's a question of the origins that are happening there. That's going to look okay. That's going to look in front there. If I click here, I'd actually be replacing this wall. Remember that, right? But there we go. All right. But trees don't belong in the dungeon. We're dwarves. We don't believe in that. So we're going to do that. I will leave Y sort enabled because that's going to be really good. And we're going to need more. We're going to need, actually, I'll leave it off for now. We're going to be re-enabling Y sort on the dungeon structure. And in fact, on this lobby town node itself and on our player character. I think, is this everything I wanted to cover for the tile map? I think it might be. There's advanced stuff you can do with tile maps as well, because you can have terrain that is set up to be sort of auto tiling and saves you a lot of effort for things like that, but sort of beyond the scope of what I want to cover over here. Do all tile maps share all tile sources? So no, because, okay, the tile map object, and this is a tile map layer technically, but this is our tile map object, refers to a tile set. What I have is I have both of these currently pointing at the same tile set, but that doesn't have to be the case. You can have separate tile sets for them perfectly fine. So my ground, like if right now, like I have dungeon tiles, one image that's got walls and floors and everything like that, but maybe I would have one of these images as only floor tiles, in which case the dungeon structure probably wouldn't need the images of only floor tiles, and the ground probably wouldn't need the images of walls. So maybe they'd be separate. But here, so it's just a single atlas that's got everything in there. By the way, these big, huge atlases like this are really convenient for optimizing video graphic memory, because you only send one image to the video card, and then you tell it which part of the image to render in different places. And it's way more efficient than sending 100 different images of different stuff. Although internally you can do some atlasing when, you know, during build or whatever, stuff like that. But this is quite good. Exactly. Hey, thanks for the sub. Okay. Next, what we want to do is we want to get a character to run around. So we're going to go into phase 2, well, or rather phase 1.2, which is getting a character going on in here. Yeah, may have yabbered up a little bit over here, but let's go and do this. So to add a character, we're going to create a new node in our scene. And what kind of node should it be? Well, again, there's many different ways to do things, but we can save ourselves a lot of headache by using a character body 2D as our base node. This is a node that is meant exactly for this. There's a 3D version, 2D version. By the thing, everything we're covering today, other than how to draw the tile map itself, everything we're going to do today works perfectly good 2D or 3D. But we'll use a character body 2D. This is an excellent starter object for anything that is meant to be a character that exists in a 2D scene, whether it is top down, which is kind of what we're working here. I mean, technically it's sort of a, like maybe we can think of this as almost like a 3/4 view with the way the graphics are drawn here, but essentially this is a top-down game, but it also works with a side view like platformer type of game as well, this character body. In fact, there's a couple of things in it that assume it's a platformer type of thing, but it works fine for this. So when I slap it down over here, oh, what was it? Is it the order in the scene? Oh, I don't know what that was a question about. The ordering does matter, because here we draw the ground first and then dungeon structure. If I drag this the opposite way, then it almost doesn't matter because our ground is basically only here, but you can see it overlap this area, right? And if I change the order here, there's also that. So you do still, the order of these layers matter for which layer gets drawn on top. And what's nice, we can also turn off some of these layers as well to see exactly what's going on below. That's totally possible. Anyway, character body 2D as our base node. We're going to rename this to player character. Seems like a good name. And then a few things. First of all, we got a little bit of complaint. This node has no shape, so it can't collide or interact with any objects. We'll deal with that soon. Let's get some visuals in here. So what I'm going to do is I'm going to go back to this lovely asset set that we've got going on here, and we're going to pull back to assets. All right, yeah, assets, entities, Not characters from this asset pack. This asset pack that we're using, the characters is this guy over here, this sort of like naked mannequin. He's got a lot of animations, but it's mostly in there, I think, as a template. I mean, unless we wanted to make like naked guy running around game. What is nice about this is it's got the 4 directional movement and a bunch of different animations that are ready to do lots of cool stuff in it. Instead, what we're going to work on is we're going to use these guys over here, which are organized in the NPC folder in this case. So NPCs, and we're going to go and put in a Knigget. So night, and we're going to bring in these graphics in here. So we need to just want to sort a few things. I'm going to create a new folder inside of characters called assets. And all we're going to do for them is bring in the idle animation and the run animation. What's nice about this assets pack, by the way, it does have I always say a sprite. I don't know how this program is supposed to be pronounced. This is an amazingly good pixel art editor. You can purchase it directly from the website, different things like that. You see, you can even purchase it on Steam if you want a convenient place to install it. It is open source, and technically you can get it for free if you build it on your own. I think there's also a fork like LibriSprite or something like that, but it's like, it's $20 and it's really excellent. So I picked it up through Steam. Yeah. I picked it up through Steam because I was like, oh, that's really convenient. And if I hop on another computer, I know I can just install it immediately from Steam, so that's okay. Anyway, we're just gonna bring in the idle sheet. Boop. And then the run sheet. Boop, over there. All right, so we've got some art ready for our character. So let's make our character visible in the game. So one of the things that I absolutely adored when I started running Godot, as I mentioned before, the decisions that people made when they designed Godot so perfectly coincide with how what I thought was the best process to work in the first place, and how it would work in Unity. Because in Unity, right, you can make a game object, and you can add a ton of different components to that game object. And I would say in my tutorials, that's probably not a great idea. Instead, what you should do is add a child game object and put a lot of that stuff in there and have sort of one for each. Because you could have your character. Like if you're making a 2D character like this, you could add a 2D sprite component to the game object itself. You could add a 2D collider to it. You could add an animation component, all these things, right? You could add 30 different scripts as well onto this one game object. But it was a huge problem when you're trying to swap certain things in and out, because things became sort of inherently more coupled, and it was a huge pain. And I always advocated, instead, make an internal structure of like the sort of the parent game object, which doesn't even have any visuals. And then as a child of that, have your visuals, and a child of that, have your collision, and so on and so forth. Anyway, in Godot, that's just how you work, because a node is only inherently one thing. And you can do more with that because your script can have all sorts of components that you can implement internally. Like you can do all sorts of fancy shenanigans, obviously, because it's programming. You can do whatever you want. But if you're not fighting the system, what you end up with is creating one new node for each one of those logical components. And it's just such a nice way to work. Anyway, so our player character, this is just the character body 2D. Let's add a visual to it. So I'm going to add a child node. And what I want is animated sprite 2D in this case, because sprite 2D is just a static image. What we want is animated sprite 2D, because the reason is our sprite sheets over here. I don't know if I've got a good image editor installed on here. Probably there's something. It's just just an absolute like vanilla Linux Mint installed, but there's probably something. But yeah, what we want to do is we want to go and add a new sprite frames object to this. And am I doing this wrong? Oh yeah, no. Yes, excellent. Okay, so now it's got the sprite frames object. And then what we have to do with that open down here, right? We've got our player character, animated sprite 2D, and then down here where we've got the sprite frames open. And we're going to define the animations this way. We don't drag the image directly in there. Just to compare, if I were to delete this, if I were to add just a sprite 2D, we would just drag a texture into there, boom, and then it would show up in the scene. Very easy peasy. But here you can see this is our idle sprite thing. By the way, this character is totally armless. The character design for these have sort of floating hands and floating weapons that you're supposed to set up as part of the animation. We're not going to bother with that. So we're going to have good old Stumpy the Knight over here as part of our game. But yeah, we're not going to use a sprite 2D. Undo. We're going to use an animated sprite 2D, and we're going to define the animations down here. First thing I'm going to do is I'm going to rename the default animation. I'm just going to rename it to idle. And I'm going to click this little button here for autoplay on load. And then what I want is I want to put the images in here, and that's going to be our animation. Now, if your animation frames are a bunch of individual images, you can just grab them all and drop them in. But that's not going to work in this example because this is treating this one image as one frame of animation, which isn't what we want. So instead, what we want to do is we want to tell this, hey, I'm going to give you this sheet of things, but you sort of have to like chop it up into individual frames. And that's what this button is for. Add frames from sprite sheet. So if we click that and then go find our sprite sheet, then we get this little interface. And we're going to say, okay, yep, it's 4 columns, but only 1 row. The sprites for this are 32 pixels by 32 pixels, which is going to be perfectly fine. Look good. Everything's nice. And we got to select of this because this sprite sheet could have tons. Our entire character animation might be in here, organized by like each row in this image could be a different animation or stuff like that. So we do have to specify which of these frames are in here. In this example, it's all of them. There's a select all over here. We're going to add these 4 frames. Okay, so now we got a little animation. I can hit play. And there you go. We have a little idle animation. Looks good to me. If we wanted it faster, we could change the FPS over here, but let's leave that in there. That's animation number 1. Let's add a second animation. So this is going to be our run animation. We'll call it run. And we're going to do the exact same thing where I'm going to hit this. I'm going to choose the run sheet. Now, I don't know why this is, but this sheet here, the sizing and the spacing is different. I don't know. It's possible that like, because of the way the steps are happening, that there's not actually enough room in a 32 by 32 to fit it in. I'm not sure what the reasoning is there. As far as I can tell, it works fine. What I would probably do is I would probably, and this is what I did in my practice session, is I opened the idle animation image and I just made it 64 pixels tall just so that it matches perfectly and it avoided a little bit of work. But this is gonna be fine. What I'm gonna do is I'm gonna say, so first of all, it's 5 slices. Sorry, it's 6 slices horizontally. And I'm gonna say it's 2 slices vertically, but we're only gonna use the bottom part. But I do want the pixels to just be 32 tiles, or 32 pixels wide, which does change that. But if we go and first of all, if I add a 16 pixel offset, and then I specify, actually, I don't have to specify anything else. If I do that, you can see that the character fits nicely in these frames here. And I'm just going to say, okay, here, 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 here. This is my run animation. Add that. And then we can hit play. There's a little dude. Seems fine to me. Okay, so now we have a character with a couple of different animations. And, oh, you know what would be nice? Let's start him inside the room. Something terrible is about to happen. If I take this fella and drag him in here, what am I dragging right now? Am I dragging player character? No, player character is still here. But the child, animated sprite 2D, is over here. Very bad. That's not what we want at all. What I want to do is I want to move the player character itself. But if I click here, it clicks, you know, it does a little mouse hit. And what does it hit first? It hits this thing. So every time I try to click here, it does that. Now, I could select player character, and then I could go over to the transform, and I could go and try to manually move this jerk ass into the right position. No, we're lazy. We don't do that. Instead, what we're going to do with player character selected, we're going to hit this button. Group selected nodes. Group selected node with its children. This causes the parent to be selected when any child node is clicked. If I do that, now if I click here, what's going to happen is it's going to detect the click against the animated sprite 2D, but it's going to look up the tree and say, hey, this is all grouped together. So whenever I click here, it's going to select the parent. I'm going to be constantly turning this on and off, depending on exactly what I'm trying to do. But oh my God. Anyway, so now if I click and drag, I'm dragging the entire player character. Cool. We'll put them, you know, roughly in the middle of the room. Awesome. And then if we hit play, let's see what this actually looks like. We haven't actually hit play on our project yet. We are very soon going to be writing code, but not yet. Anyway, first things first, when you use the normal play button over here, it plays the project as a whole, and the project needs to have a initial default scene to start in. That hasn't been defined, which you can do in project settings, but you can also lazily just say, yeah, you can just select the current one. That's going to be fine. So now it's going to do that. Oh, I don't know. I had the little double image. There you go. It's loading up. Boy, that's awfully small. Maybe we'll do something about that. One thing I'm going to do here, because I'm running my Linux version over here, I'm only running 1600 by 900, and then I'm upscaling it to 1080p as a cheap like magnifying effect to make all the fonts bigger and easier to read for people who are on the little mobile devices. But it doesn't leave me with a lot of screen real estate to play with. Now, I mean, I could just shrink this window down, do different things. What I'm going to do is, I could have done it from that window, but if you go to the game tab, if you click these 3 dots over here, and depending on your version of Godot, they moved it for one of the versions. I don't know. I'm on 4.7.1, which is the latest, but I think 0.0 changed where it was, and then maybe they put it back. I don't know. There's another button over here to click. Anyway, if you do this, if you just toggle this off, make game workspace floating next play. If I turn that off and I hit play, it's just going to run in here, which is going to save me real estate. It makes it even smaller though, but for our purposes of a tutorial, I think that's going to be a little bit better for me. So I'm just doing that. You don't have to if you're following along. Anyway, but it's clearly very small. I think what we want to do is we want to embiggen the visuals here, right? Because the 32 by 32 pixels for our character on a modern screen is going to be fairly tiny. There's a bunch of different things we can do. The worst thing we could do is, say, on our root object of Lobbytown here, I could go in here and in the transform is I could scale things up. I don't think that's what we want to do. Maybe it will though, because it depends on exactly what you're trying to implement in different places. The other thing we could do is we could use a subview. That's a really, really powerful tool. We wouldn't do this as a child node, but the sub viewport over here lets you do interesting things where everything within it will render at a certain resolution, but then the viewport itself can be embiggened and do different things. This is also a great way for doing like fake screens and like maybe a 3D game, right? You've got like, you're walking by and there's some computer screen and it's like a live screen or whatever. We just render everything to sort of sub viewport. This is also really handy. I was using this for some of the UI stuff as well, because you use sub viewport and sub viewport container as a way to do some interesting UI scaling. It's a really powerful tool. Maybe it'd be the right thing to do. Maybe the scaling be the right thing to do. And it'll depend on your game. In this case, I think all we're going to do is I'm going to go project settings, window, and there's a scale option over here. I'm just going to make everything 3 times as big? Maybe twice as big would be enough. There you go. You know what? Actually, that looks pretty fine to me. 3 times as big is what I'm going to do. Now, then there's all sorts of other things you got to consider, like what happens if you're running your game at different resolutions. That's going to be out of scope for this, but the combination of viewport width and height, and then the stretch mode and aspect over here, these are going to be really powerful tools for adapting your game at different resolutions and things. But yeah, I'm going to say a little bit out of scope for this one. Also, our view isn't centered. We're going to fix that later with a camera once we do some movement in here. But anyway, so we've got that. We've got our character in place. That's cool. Let's get our character moving. Now, what we're going to start off with, we're going to write our first script. Over on player character, I'm going to right click and choose attach script. As always, there's 30,000 different ways to do things. You could also, with the player character selected, you could go down at the, that'll be behind my head. You could go down here, and then you could create a new script that way. I don't think I ever end up doing that. I do a lot of the right clicking. Then the other thing you can do is you could write the script first. So in our, we're about to write a character script. So let's make a folder for scripts inside of characters. And over here, I could go right click. I could say create new script and start that way, and then just drag it onto the player character to attach it. Everything perfectly fine ways to do things. Anyway, I'm just going to go ahead and right click and attach script, and we're going to write a new script. I'm going to be working in C#. Again, nothing wrong with GDScript. It's a wonderful language. I like working in C#, so that's what I'm going to do. And then you can choose to start with no file at all, right? You could have it based on no template whatsoever, but let's go with the recommendation of templating it based on this character body 2D. That's cool. All right, and it's going to call this player character. No, I'm going to change this, and instead what we're writing here is a character motor script for reasons that will become obvious as we go forward. Boop. Right. Okay, VS Code, the first time you want to start it, I think it's trying to like log into my .NET account or something, which I don't have. So it's like, no, screw off. No, I don't need the LLM chat integrated, any of those things. Oh, it's all in there by default. You can't just be doing your own thing anymore, can you? And yeah, the only reason I'm running in Linux in the virtual environment over here is just to make sure I've got a clean little thing, but I'm not presupposing anything about your setup. And also it means that I can't actually dox myself. I'm always worried when I'm like screen capturing for my desktop. It's like, oh, am I going to like accidentally open my browser with my email tab and like ruin everything? Yeah. So this is just a little easier for me and not have to worry about that. Let me know about the font size. Again, one of the other things with the virtual machines, I'm running it natively at a smaller resolution and upscaling it to try to embiggen the text, but I can also embiggen the text further. Yeah, you can disable the AI features in VS Code. I've done nothing to customize VS Code. As far as I know, this is just running purely as it would out of the box. The one thing is, the first time you load a C# script in here, it will ask you if you'd like to install the C# dev kit extension, which you want to say yes to that. So it'll do that, and then it'll install the C# extension at the same time. But that's just what you want for just, language highlighting and everything like that. And it is going to be aware of Godot and the and be able to autocomplete from Godot and all those things because it's loading in the project and the solution over here. So it knows about the Godot assembly and everything is groovy. Anyway, oh, did I create the script in the wrong place? I did actually. So actually, no, you know what, Anders, or dot. I don't know how you pronounce your name. This is a great example. I did this on purpose. This is operating under level, first of all, so it's really wrong because clearly we want under characters and scripts over here. So how do we go about moving it? Well, if you're in Godot, all we see is character motor.cs. But when we're in VS Code, you see the .cs.uid file as well, this partner file, which just has this unique identifier in here. When you're moving these files, if you're moving in Godot, it will move both those files at the same time because it wants to keep them together. If you do the move outside of Godot, move both files together. So if I want a character motor to be in this character scripts file, what I'd really want to do is grab both of these. And the reason is there was always this issue of, this is mostly if you're creating, hang on, let me try to manufacture an example. Public packed scene example. All right, if I do this, do I have to put the export tag if it's public? Yeah, I think I still have to put the export tag. Well, my quick example is being less quick than I expected. Come back over here, rebuild. Why don't I see it here? Anyway, this is what you get for trying to do an ad hoc little example. If we had a field that was exposed and we're dragging something in and creating that link, then is it because it's not a public property? Should be exposed here. What am I doing? Anyway. Same thing with these speeds and things. Is character motor not actually... No, it's on there. Oh. You know what? I think it's because we had a bad link. Oh yeah, I clicked on it and it tried to open something empty here in a folder that doesn't exist. Okay. That's interesting. It didn't actually update the link as I went. So let me go and character assets. There it is. Oh. But this is sort of exactly what I'm kind of trying to talk about here, is if you have some reference from your file system linked into a node, and then you move the object, Godot should be able to follow that link as long as you move that UID file. It didn't in this case, but maybe it's because I didn't do the build ahead of time, or maybe it's a quirk of working with C# as opposed to just like talking about some other generic asset. That's entirely possible. But anyway, yeah, it was trying to point to a file that didn't exist anymore. It didn't update its link. But there you go. So it shows up over there. Anyway, the whole idea is if you move the UID files, theoretically, Godot will know how to maintain that link along the way. Anyway, it's in the right place. I am back where it should be. This file over here is the file that Godot auto-generated for us when we said we're creating our own custom class, character motor, or script. Now, because Godot refers to these things as script, I will also tend to use the word script. Whether the word script applies correctly here, whatever. But anyway, so we created the custom class character motor, which inherits from character body 2D. It is a character body 2D with some extra stuff on it. And Godot went and auto-generated this little example for us. And you can maybe tell at a glance immediately from this example that, hey, this has sort of platformer smells on it, right? Jump velocity. Okay, well, we're not going to need that. Yeah, because we're not a platformer. Hey, are we on the floor and is there gravity, handle jump? Yeah, we don't need any of that stuff. So let's just go and cut that out immediately. We're gonna be cutting out all this stuff, but for the moment, let's just leave here. And what are we left with? Physics process, so this runs once per physics tick, which by default in Godot is 60 times per second. What this does is it grabs the velocity. So the uppercase velocity is a member field on character body 2D. Actually, I don't even know if it's from character body 2D or from one of the base ones. It might be character body 2D itself based on this tooltip itself here. So that's the speed at which our character will be moving. We just go and grab it into local variable so we can do some manipulation on it based on the inputs, which the fact that this is UI underscore left and so on and so forth should also give you a little bit of a kind of a like, well, that smells weird, but sure, let's go for it for now. Anyway, and it's just going to be setting a little bit of movement here. It is different than the example I was thinking of from before, because it's kind of overkill. But anyway, if we do this, in theory, we should be able to WSAD and move around. Let's see. We're going to be rewriting all that shit, but nope. Oh, we are still missing an object over here. Possibly that's what's blocking. We will see. So we still get this exclamation mark over here. You can see this node has no shape, so it can't collide or interact with objects. I'm actually not sure if this is going to fix things. Oh, you know what? It's also possible, now that I think about it. Yeah, never mind. So it's those directions are on the arrow keys, not WASD, which is why we have to customize all that. I also can't move up and down because, again, it's expecting sort of platformer mechanics. That's why we got to rip all that stuff out. But hey, we got a character that can move around. That's very exciting. I'm going to leave this here until we need wall collision. Let's not worry about that for the moment. Anyway, let's go and rip all this shit out. And then rewrite some of it because of reasons. So what we want to do is we want to tell this velocity vector, this is the speed we should be moving in. And what we're going to do is we are going to read the direction at this stage in the game from input dot get axis. No, not get axis. Actually, you know what? I'm going to save myself a bunch of typing. Get vector. That's what we want. Let's get rid of this stuff. Let's get rid of this because we're going to be writing this. But let's keep this first call somewhat as it is, right? We're going to be getting a direction and this input.getVector. And these set of strings, I don't like it because it feels a little bit magic-y. But these strings are inputs. If we go project settings, input map, we can define an input map over here. This is a really good way to define hotkeys, because what we could do is we could read directly, is the W key being held down, the A key being held down, and so on and so forth. But then we could go and implement our own way of defining those various hotkeys so that we can do a settings menu where we define hotkeys. Godot provides a lot of that built in for us if we just go to this input map. What I'm going to do is I'm going to add a new input. I'm going to call it left. You'll never guess what this is going to do. And I'm going to add it over here. And then we're going to have a right and an up and a down. Right, so these are inputs. Now, if we go show built in, we will see a bunch more in there, including there's going to be UI left, UI up, UI down, which is sortable. There, UI left. This is the one that was built in, it was being called, and it does respond to a few different things, including the joystick buttons and things like that, and left. But we're not going to use these built-in actions. We're going to leave them in there, but we're just going to look at our own. We're going to define left. So we've defined an action named left. We just have to tell Godot, hey, where does that input come from? And we can go and we can search through all this and find the right one. We can be like, okay, so left, so this should be the A key. So if I keep scrolling, I was going to say if I missed it. No, there you go. We want it to be the A key. Obviously, we're way too lazy for that kind of thing. So what we're going to do is we're going to click up here, and it's a little misleading because it says filter by event, but if I click here, it says listening for input instead. Okay, sure. And if I hit A, there, it detected that. Now, what's interesting about this is based on the position on the US QWERTY keyboard. The nice thing about doing this way, if someone's using a different layout, like if someone's using a ZERTY keyboard, right, where instead of QWERTY, they're a ZERTY, the A key is in a physically different location than on the standard QWERTY keyboard that most of us are probably all using. But this is actually just checking the physical location of it, not whether the character that was inputted was actually an A, but literally the physical location where the A key is on a standard QWERTY keyboard, it's using that one. So that way, even if you're using a ZERTY, yes, you're not actually hitting W, A, S, and D, you're using Z and some other keys, but it'll still physically work. Anyway, you can do that. You can also add all your axes in here. So this would be joypad axis 0, for example. This is the movement towards the left, so we could go and throw that in, and so on and so forth. I'm not going to worry about defining the joypad stuff, but I will want to say, hey, I'd also like to support clicking left. Cool. And then we're going to go D for right, and then the right key. And then for up, I'm going to hit W. And then I'm going to use the up key. And then for down, I'm going to use S. And then also the down key. Boom. Excellent. All right. So that's in there. And our actions are just named left, right, up, and down, which is good. So then we can go back into our code. And now instead of reading UI left and so on, we're just going to go left, right, up, and down. Good. And then that's our direction. And then for our velocity, what we're actually going to do, and we can get rid of a bunch of these temp placeholders here, but just for the sake of what, well, you know what? Sure. Let me get rid of that and that. And all we're going to do for velocity is set direction times speed. If you've done any of this sort of programming before, you're used to these sort of like update ticks, whether it comes from Unity or Godot, where you've got a time delta over here. And you might think, oh, I should multiply the speed by delta. But that's already happening. Move and slide is a function that is provided by character body 2D. It wants a velocity set to a velocity, not pre-multiplied by the time delta. What about that, numpad gamers? Well, there you go. Just throw it in, and it'll all be in there. Anyway, now we should be able to move around with all keys. Hey, very simple, very straightforward. All right, excellent. And then we can, oh yeah, we can roam all the way around the map because we never implemented any physics. Now, by the way, this super duper does not belong in character motor. We're going to be pulling this stuff out of character motor in a little bit. Also note this speed is defined in pixels. Pixels per second. I think it's a terrible idea to think about your game in terms of raw pixels when it comes to defining character, like movement speed and things like that in pixels and that sort of thing, right? If we're thinking about an action RPG, we really want it to be data focused as much as possible. And what if, okay, so for now, sure, everything looks good while we're using 16 by 16 tiles, but what if we switch to 32 by 32 tiles? But we still want, so we want more details in the tile, but we don't want our character to suddenly move at half the speed, which is what would happen, right? Because there'd be twice as many pixels. So instead, what we probably want to do is think about our character speed in terms of, how about tiles per second? Let's say we define our character speed as, I don't know, 5 tiles per second. And then we probably have some sort of like, you know, singular source of truth somewhere else that defines something. Whoa. Like this could even be an integer, but let's say it's a float, which is some sort of world units to pixels, which is going to be defined as 16. And then over here, we're going to be converting. We could make a little helper public. In this case, I guess I'd go float speed in pixels. And we do a little lambda, which is just returning speed times world units to pixels. Did I get that syntax correct? So if we do this, well, we're moving slower than before because this is not 300, but I think I did that right. There you go. Oh, good question. Was it 16 or 32? So our character graphic is 32 by 32, but our tiles are 16 by 16. So I'm going to say, like, what I'm concerned about is defining the world in terms of tiles. This also applies if you're working in 3D, right? I said everything we're working here also applies to 3D. Obviously, we'd be using 3D model for the world and 3D model for the characters, but in there, it would be the same sort of idea of what is our dimension. Now, in 3D, it tends to be a little bit more natural because usually the default assumption is that you treat the world as one world unit as 1 meter. And for this kind of game, it feels very appropriate to be like, yeah, that's it. But the important thing is we could change it, right? You could decide, you could implement all this game logic and then realize, you know, I think the world needs to feel bigger. So I'm just going to just internally change something about my scale, but then your logic will stay the same. Anyway, what I want to do is I want to define my, if I've got, I don't know, a fireball skill on my character, I want to define my fireball as having a range of up to 10 tiles and a radius of, say, 2 tiles. for the explosion. I want to think of it that way. And then later, because later, if I change from 16 by 16 tiles to 32 by 32, I don't want to have to go and redesign all my logic. I want to have one place that converts my world information to that. So anyway, we've got this sort of set up. Excellent. Our character can move around. Let's feel a little sluggish. Maybe I'll bump it up to 10. Actually, yeah, if I do this, this is about half the speed as before, because this is 160 tiles per second, or 160 pixels per second. There you go. That feels all right. Excellent. We obviously want our character facing in a couple of different directions. We want to fix a little bit of animation in here. I got the animation. I don't have the run animation yet, but you know what? I'm going to say that's fine for now. Let's move into the physics fixing. Let's make it so that our character bumps into the walls. So 2 things. First of all, our character needs some sort of physics information around him, and that's what that exclamation mark is here, right? Add a collision shape 2D. Cool. Let's do that. Let's add a child node, collision shape 2D. And then we're going to get a new complaint because this actually needs a shape to be defined. So that's over here is the shape. And for this, I'm going to use a circle shape. Capsule shape is very natural for a 3D thing and could be very natural for a platform or this sort of thing like this. But for our collisions and for being impacted, we are going to want a capsule shape. But for our collisions, I'm going to want a circle. And the thing is, I want the circle because what I want is the collision to be around his feet. And it's going to be really evident as to why that's the case in a little bit. Now, I want this collision circle to be around the feet, not in the middle of the body. I could move the collision circle down, but what I think is going to be much better is for us to logically think of the character as the character's origin to be here, because that's where it is, right? Character player's origin is right here. And really, we want the character's feet to be lined up at the origin. So this animated sprite 2D, I could go and move this up. As opposed to, instead of moving it up would be via the transform, I'm going to use the offset over here, but it's going to be the same sort of thing. I'm just going to change the Y, oops, by -16. There you go. -16, you can see his feet are perfectly aligned with the origin point, and that's going to feel really, really good. Now, our circle is still not correct. So, okay, let's go to the collision shape, but we'll do a very, very similar thing to that. Now, again, I could mess with the transform, but I could also go and mess with the shape, which is what I'm going to want to do. Well, first, I want to mess with the shape because I want to change the radius here. I don't want to scale change, but I think it's going to be too big. I'm going to call it 6, maybe 8. We can keep fudging it a little bit as we go, but I do want to move it upwards to, actually, I think -5 is going to feel pretty good. Because -6, right, it'd be the same as the radius. Oh no, it's a radius of 8. I think I like that because I think I want a little bit of a gap over here for reasons that'll become obvious in a moment. Anyway, we have that on our character, but he still can't collide with the walls because the walls don't have any physics. So what we have to do is go back to our dungeon structure over here. And then we're going to go into our tile set, not tile map, but tile set. We're going to go back to this paint tab, and we're going to change what we're painting. We're going to paint physics. We can't paint any physics. Create and customize physics layer in the inspector of the tile set resource. Our tile set needs to have at least one physics layer defined. Now, there's several different ways to access this. From the dungeon structure on the tile set, I could click here to expand it. If the tile set is a resource, which it is in our case, we can also double click. And we get this view. This view here, as a reminder, is exactly the same view as if from dungeon structure we expanded this. Exactly the same thing. We're modifying the same thing. Anyway, what we have to do is go here, physics layer, add element, there. We may mess with these collision layers and collision masks later on. We could even go and rename them if we wanted to. We're not going to mess with any of that right now. Everything that exists in our game right now is just going to be on collision layer 1 and collides of collision layer 1, our character and our walls. Now that we've got that, let's see what happens if I hit play. Oh, right. Duh. I haven't started painting yet. So we're going to go back into our tile set. And now, if I go paint and then pull this down, now I can choose to paint on physics layer 0. And what I'm going to be painting is a collision box. Now, if I go, I don't know if there's a good 1x1 example that I can use. I suppose not. But we're going to be focusing on this wall over here right now, which is our well, actually, you know what? Okay, let's think about this right wall. That's a good idea. Let's think about this right wall. So the right wall is this over here. With physics layer 0 selected, if I click here, I have just painted this collision box on top of that. Let's see what happens. Now I should be able to run into the wall on the right. There you go. Excellent. Cool. Groovy. Let's keep doing more of that. So let's do the same thing. So again, we're in tile set. I'm on paint mode, so I'm going to do this, and then I'm going to do this. Good. And then, you know what? Maybe the corners over there. Now, this is specifying the whole tile as a collision box. Give me a second. Now, let's work on this wall part, right? This wall over here, we don't want to be able to walk through this wall. So we're going to click here, and what's it going to do? It's going to put a collision box on the bottom here. Now, as it turns out, I'm going to suggest that that's probably correct. But let's look into exactly what this means here. If I hit play, now if I move up, and because of where my hitbox is, right? On my character, my little circle area is down here, not under the head. That's why I put it there, so that the head could overlap the wall. That looks good. If the hitbox was in my entire character, I would be stopped somewhere around here, and I wouldn't be able to move up any higher. And that doesn't feel right. This feels about right. What about on the bottom? That's good. I left in a little bit of a gap. I found in my testing that if I made the that collision circle exactly flush on the bottom, by the way, we may have been better off using a collision square. That's for our character as well. But I think the circle feels pretty good. I really found that leaving a tiny gap in there felt better. If the feet were directly flush, it wasn't any good. Now, of course, I can pass through the door. I haven't defined a hitbox on the door, so we're going to walk through here. And from the other side of the wall, well, we got a few things. First of all, so I'm colliding here because that's where the hitbox is. And you're like, okay, I guess that's right, but should I be able to see my character over here right now? I mean, I'm not making a Spider-Man game. I don't think my character is supposed to be up here. What's the deal? Well, again, we've got to think about the Y sorting. What's going on with our screen here is everything on the scene node gets drawn, in this sense, top to bottom. So Lobby Town, which isn't anything, there's no drawing there. It draws the ground, then it draws the dungeon structure on top of that, then it draws our player on top of that, regardless of where our player is. But we clearly want the concept of if our player's behind this wall, he should be behind this wall. So this is where we're going to go with the ordering, the Y sort enabled. Now, I'm going to turn on Y sort enabled on my player character, and we're still not going to be right. In fact, I can confirm that in the editor. I don't have to go and run the scene. Yep, that is still not quite right. Well, okay. Oh, dungeon structure. What I should do is, not on tile set, but on dungeon structure, ordering. I should turn Y sort enabled. Still not working. Well, because this Y sort enabled is making sure the dungeon structure internally to itself is doing Y sorting. And on the play character, it's making sure the player character is doing Y sorting. If it had multiple parts to it, like arms and things like that, there'd be some different Y sorting. But on Lobby Town itself, even though Lobby Town doesn't draw anything, I have to tell it Y sorting enabled, and there it is. Now, in fact, I think if I go back to the dungeon structure and turn off Y sorting, oh no, I do still need that on. There's some things that you don't need it on every layer, and some things you do. There. Now my character, despite the fact that he's later in the tree, and therefore is being drawn later, it's correctly not drawing over the wall over here. And if I move the character, we can see, okay, so over here, he's clipping through the floors. Well, ground, I actually don't want Y sorting enabled on the ground. The ground, I don't want Y sorting enabled because it should always be rendering behind things. There you go. So I've removed it from the ground. I still have it on the character, and I still have it on the walls. Now, you won't be able to do this motion in the game because you'll be stopped by the physics, but we can see the exact point where we're transferring from in front of the wall to behind it. Now, by messing with the actual origin and the Y sort index, right? That's one of the things we saw when we were running on our dungeon structure and tile set, right? I changed, when I was painting my walls here, I was changing the texture origin, which is very handy. There's also the Y sort origin. And what I could do is by changing this, I could determine exactly at which point my character is in front of the wall versus behind it. I'm going to say that's not required in this situation because my character, this type of game that we're doing, my character will never end up here. And if he does, maybe he's doing a little hop and he should still be in front of the wall. But then at some point he's behind the wall. For our purposes, this is going to be exactly perfectly adequate. All right, that looks good. I'm not going to put a hitbox on the door right now. That's going to be fine. And then behind, everything looks pretty much the way it should be. Lovely. Okay. We haven't added a hitbox to this little wall segment yet. And it's because I want to do something a little bit more special. So with this wall segment, oh, and I also want to remind some of the annoyances of drawing the hitbox, right? If I'm modifying tile set, I'm modifying the texture origin. I guess I should, hold on, sorry, not texture origin, I'm modifying the physics. I should acknowledge for this wall, right? What if I wanted the whole wall to be a collision? What if I didn't want my character to be behind it? What would I do about that? Well, you're looking over here, you're like, oh, I think I've got it, right? I'm going to go and I'm going to take these little points and drag it up. And oh, they're quite tricky to land exactly right. How do I get some precision? It's okay. This little button over here, grid snap. Now it snaps to a grid. So it's very easy to cover this entire wall. Or maybe, I want to cover it to here. If I do, oops, by the way, you can create extra nodes, which we'll be using in just a moment here. If I do this, then it covers most of the wall. Except remember, I'm not editing this right now. I'm setting up my brush. If I want this to apply to my wall segment, I have to click. Now it's applied. But now if I did this, I'd only be able to get into a little bit of the wall, and I wouldn't be able to get any lower. So how thick do you want this wall feeling? That's what you control over there. I'm going to suggest in this case, I was quite happy with what I had before. So what I want to do is go back to my tile set, and I want to revert this. The easiest way for me to do it is to grab the paint dropper, grab one of these tiles where it's a normal sort of single tile square, and oh, I'm clicking on the wrong tile. And that, there you go. I've reset that there. But let's take a look at this guy. So let's say I was trying to apply this hitbox over here, right? This is not right. This won't feel right for a few different reasons, because it's extending too far south, and I can't get as close to this wall as I should. And not to mention that the hitbox is too far south, where some of this wall, all of a sudden, I can get lower here than I really should, and it's no good. So let's go and customize that hitbox a little bit more. So first things first, I might say, okay, well, I don't want to collide. This bit at the bottom isn't supposed to be solid ground anyway. So it should go and not be part of the hitbox. But the other thing that's going to happen, and so if I paint this back on there, that'll be the case, right? Now I can scooch right up to the wall. There you go. That looks about the right distance. But what's going to be really annoying here if I move to the left, I get stuck on this wall, and it feels terrible. So what I'm going to do is I'm going to make a little change over here. I know it's quite small. Let me embiggen this and embiggen this so you can see what I'm doing. I'm going to delete one of these points by right-clicking on it, and then drag this one over here. And again, you can create points just by clicking. Depending on what mode you're in, you can create new little points. To do that, I'm going to delete that. I'm going to have this wedge-shaped instead. And now what's great about that, oh, I forgot to paint it. Boop. Even though that doesn't match the graphics, look how nice that feels. Sort of just shoves you out of the way. The little things that help. Okay, good. We got a little physics. Lovely. Yeah, nice and smooth. Excellent. Okay, so I'm going to call all of phase 1 done. Yeah, let's go and make the animation a little bit better. So what animation am I talking about? Well, we have on our character, we have a run animation ready to go. I have a whole run animation, but it's not playing at any point. I should probably get it to play. Also, our character only ever faces towards the right, which doesn't feel really good. So what's our solve there? Well, in my character motor, just like I also read inputs, I could also put in animation handling. Terrible goddamn idea. Yeah, you could have these God scripts that try to do everything, but that becomes really painful when you're trying to break things up. Plus, okay, this is supposed to be character motor. The term here, what I'm calling it here, is because it's responsible for moving this character around. This is probably also going to apply to non-player characters like monsters. And then it's going to get even weirder when we're talking about networked players, right? Local versus network players. So now you're joining on a little bit, 1.5 grid tall. The hitbox, I'm trying not to fiddle too much of the hitboxes, even though I already have way too much. I want this character. Are we not going to get a multiplayer today? No. I do prattle on. Anyway, this is supposed to just move the character around. If we start giving it tons more responsibility, it makes it way harder to break up. So what we're going to do is we're going to switch things a little bit with our character over here, is we're going to create a couple more subnodes. And we're going to actually create a child node, and we're just going to use node by itself. This is just a absolute vanilla node. It doesn't know anything about its space in the world. It doesn't need to. But it's a great thing to hold purely logical code. So I'm going to create a script here that is going to be called the player input script. This is what actually is supposed to interact with the keyboard. Oh, and again, it put it in the wrong area. Okay, I got to change my organization a little bit. Yeah, player input. I'm going to move it in Godot here so that the move works correctly. And I'm going to rename this as well to player input. And then I'm going to create another node, another vanilla node. I'm going to call this one animator. And it's going to control what animation is being played here. Now, in practice with some of these characters, what we're probably going to want is like animation trees and like for more complex animation. All we're going to do is we're going to interact with the animated sprite 2D and change which animation is playing. That's all we're going to be doing with the animator code here. I guess the easiest thing to do might be for me to create the script in the right place in the first place. I don't know if I do this. I guess I can change the location. Maybe, part of me is wondering, maybe I should just put it in dump it in the base one, because it's like not in level. Actually, yeah, I'm just going to select characters, scripts. Let's do it right. And animator. There, good, excellent. Boom, create, lovely. All right, and in the interest of time, I'm going to make sure to open my reference files in the other one. I've been writing these mostly on the fly so far, but let's get these working a little bit cleaner. So character motor, we're going to take this input stuff out of here, and we're going to move it into the animation branch. So the animator, not animation, in player input. So player input is going to be responsible for reading the keyboard input and later on mouse inputs as well for click to move, pathfinding, things like that. But we're going to keep it as simple as possible for the short term, where we're just going to be doing the character movement. So in here, we're going to rip out this whole direction code over here and move it into the player input script. Now, where in the player input script should it be? Right? We've got a little process node. And you remember, there's process and there's physics process. Physics process runs every physics tick, which in default settings is once every 60 seconds. Process runs every visual frame. And the two have nothing to do with one another. If your monitor is running at 144 frames per second, then that's what's going to happen here. If your CPU or your GPU is bogging down and you're only getting 20 frames per second, that's all that's happening here. Meanwhile, the physics system is trying to work its own stuff in the background and arrange things. We probably want these to be in sync. You don't have to. In fact, what I always used to say when I was working in Unity is I would often say, read the inputs during update in Unity, which is the same as process, and then apply them using fixed update, or in this case, it would be physics process. I think in this case, we could probably link it together. And in fact, what's going to happen later is, so this first pass here, this is effectively going to be a push process where the player input script is going to be reading the data and pushing that information to character motor. Later on, I think we're going to want to invert it so that character motor is pulling from a sort of move intent interface is likely what we're going to be working with, but I think that's going to be out of scope for this over here. But yeah, let's change this to physics process. So that's going to run at the same time. So every physics tick, this is going to process some inputs, and it's going to pass to the character motor. It's actually going to be one frame behind because of the way things are ordered, which is why we have to change it from a push to a pull later, but let's not worry about it right now. And then what we're going to do is we're going to very naively in character motor, we're going to expose a public vector2, which is going to be move direction. And all it's going to do in this logic here is every frame, it's going to set its velocity to move direction times speed in pixels and that. This, we're going to have functions to set these because we're going to have different movement modes and everything later on. But for now, again, simplest thing first, just get it working and then make it better later on. Just expose move direction. And then over here, all we're going to say is, okay, every input in here, we're going to read this because the idea is our monsters aren't going to have keyboards. Instead of player input, they're going to have monster AI as a script, right? But they're both going to have to set a direction for the character motor move in. The character motor shouldn't care where those inputs are coming from. All it cares is that someone's telling me what direction to move in, and that's all I give a crap about. So we will need a reference to character motor over in player input. So we will do that. Character motor, and we will call it, well, it's going to be underscore character motor. I think if I had, actually, I should have let it autocomplete. But let me try this. If I had set private in the first place, I think it would have offered up the autocomplete. Oh, that's interesting. It doesn't suggest with the underscore, which is the standard in Godot and Microsoft coding standard, I think, for private fields. Anyway, we've got this character motor, and this is the thing we're going to then send. Character motor dot movement direction. We just want to set it to direction over here. Obviously, we could make this a one-liner, but the other thing is there might be extra stuff in between that happens here later on. So there might be a reason to store it here. This all gets compiled out, so it's not adding any overhead whatsoever. In theory, well, except that I haven't set this yet. In theory, this should work exactly the same as we had before. The question is, how do we get the reference to character mode over here? The sort of Godot integrated way would be to set an export on this. And then if we do that and head back to Godot and then the player input, we do have to do a little build to make sure it's up to date. Then what we could do is we could drag the reference to the character motor like that, and then that would work. The other way to do it, and I'm usually a fan of finding things programmatically instead. The other way you could do it is you could find it in here, right? I could go and get from parent, get parent character motor, and we could set it here. And then remove the export if we wanted to. And then we'd just be setting it in code. Which way is better? I like grabbing things in code personally, mostly because I'm always like, I sort of don't trust the inspector, right? So now if I've done this, it's no longer exposed over here, but we're getting it in code. We're not currently checking to see if it got a valid one, if this returns null, or if there's a class mismatch, it'll complain right away. If it returns null, then we'll get errors when we try to set over here, which is fine enough. Anyway, let's make sure that things still work, because I think they do. There it is. Yeah, see, we can still move. So yeah, the whole idea with this, by taking character motor, making it just about moving the character, this can be reused for all our different characters. Player characters, NPCs, enemies, and then when we get around to networking, it's going to be really hard to have that, really important to have that division. Same thing with the animation. Why should the script that is responsible for moving the character around give a crap how the character is animated? The answer is it shouldn't. It should have no concept of that whatsoever. But the animator is going to do something very similar to what the player input is going to do. It's going to go and it's going to try to get an instance of character motor. And then what we're going to do is we're going to check to see what our character is doing in terms like a physical movement. And then we are going to change which animation is playing based on that. Where's my little example? Because I don't want to have to. Oh, right, I called it player view in my previous go, but I think animator is going to be fine. So we're going to grab a copy of the motor. Oh, we all need another copy as well. We need a copy of private, our animated sprite 2D. Oh my God, my fingers just miss sometimes. Animated sprite 2D. We'll do that, and then I'll add the underscore. I don't know if I can train the autocomplete to work the way that I want. And then we want to get a node. Where should this be organized, actually? This is sort of a sibling node. Maybe I should have just done it with exports. You know what? It's going to save me a tiny bit of typing. I'm going to export this, and we'll just set up the link over here in the interest of speed. Compile, go to animator node. There you go. So it needs the animated sprite 2D reference. There we go. Okay. So now, in this script that we've got, we can manipulate this. I mean, I guess I could have added the code to animated sprite 2D, but no, I don't think so. I guess with this setup, that would actually work fine. The reason I didn't is because later on, if you're doing things with animation trees and stuff, you're really going to want this as a separate script. So anyway, it's all going to work out in the end. So we've got that. We're getting one way. We're getting one another way. Don't do this, but I'm just worried about time, so I'm trying to speed up a little. Okay, and then I'm wasting time explaining it. What we're going to do here is we're going to read the velocity. So the interesting thing about character motor is move and slide is what moves us physically. It moves and slides across surfaces, right? If you're bumping diagonally against a wall, it'll sort of slide you around a wall. The interesting thing is after this is done running, it actually changes velocity to represent that. There's also a slightly different one, which is get real velocity. Velocity gets modified by move and slide, but it still does something slightly different from get real velocity. This is very relevant if, in a platformer situation, if you're moving up a slope. It's also, the difference is very relevant if, let's say your character's on a platform and the platform is moving. What is the character's velocity? Well, do you want the speed at which the character is walking, which is important for animations? Or do you want the speed at which the character is actually moving, which might be important for calculating dodge chance or something like that, you know? Anyway, we're not going to worry about it in here because it's mostly all going to work out just fine the same way, but I did want to put in a little note that there's a slight difference. Anyway, what we're going to do is if our character motor dot velocity, which is a public thing that we can read, if its length is more than 0, then we are not standing still. Therefore, we are going to play animated sprite 2D. We're going to play the animation called walk. Now, obviously, there's some hard coding going on in here. We might want to expose it as a property that gets set. The other thing that's nice to do is something like private string, not string, const string name. And these are optimized in different ways to make it so that two string names that have the exact same text get stored just once and things like that. Anyway, And they're also immutable and various things. But anyway, we'll just go and do this. If our length is more than 0, then we'll walk. Else, we will run the idle animation. We're going to do one other thing, which is if our velocity is greater than 0, then also we're going to flip ourselves left and right, depending on the direction we're going in. So animated sprite 2D dot flip h, set to true or false. And we're just going to say if our character motor dot velocity dot x, if it's less than 0, then flip us to face the opposite way. And now we should have a character that still plays the idle animation while still, and while moving around, fires off a million errors. There's one. Oh, did I call it run? I called it run. The one thing I hate about the strings and stuff in here is you don't get compile time errors. You just get the runtime errors. But there you go. Doesn't it look swell? All right, let's get some multiplayer going on. I think the stream will go a little long today, and I'm okay with that. So for those of you who skipped the previous things watching on YouTube, we've got a little character who can move around, and we are now going to start working on the multiplayer. So there's a lot of multiplayer theory that we could talk about because every game has slightly different requirements when it comes time to how they implement multiplayer. But I'm not even talking about little edge cases. I'm talking about like the larger questions. One of the largest questions you might have is something like, where is the simulation running? Where is the authority for the simulation? Because if every computer is running their own copy of all the game logic, surely that's a terrible thing. Well, not always, because there is a method of multiplayer implementation called deterministic lockstep, which is used a lot in heavy-duty strategy games where there's a ton of different data, because it would be impractical to have just the server crunch everything and then send all that information 30 or 60 times a second to all the connected clients. It would be completely impractical. And so what happens instead is you end up designing something where each computer does run their own simulation, and all you do is send the sort of the command inputs, the intents. Examples of this include StarCraft, Factorio, and all those paradox games we love to play. Because when you load up a game of, say, Europa Universalis, it takes several seconds to load up that save, right? There's a lot of data. Obviously, you can't have the host player zip up that save and send it to every player 30 times a second, right? That's completely impractical. So instead what happens is you design a game where, and let's consider StarCraft for an example, where instead of sending the constant update to all clients about the position of every single Zergling on the map, instead what the command is, I as a player have these 12 Zerglings selected. I'm commanding 12 Zerglings to move over there. And all you do is you send the command over the network is, these 12 Zerglings have this point as a destination. And that's it. And then each client simulates it on their own end. Now, the reason it's called deterministic lockstep is because you do have to make efforts to make sure that every client truly resolves everything in exactly the same way. Otherwise, and this is something we're very familiar with some of the paradox games, you get out of sync errors, right? If I click the button of I want to build a foundry in Provence, then every single connected client has to go and initiate the construction of that foundry on the exact same game tick, and all the math about it has to be done in exactly the same way, which is trickier than you might imagine because different processors actually do floating point mathematics differently. So if you're using floating point math, it can break. Depending on how your random number generators work, that can break and you get your out of sync errors, and it's terrible. But that's also when you think about Factorio. I thought for ages, multiplayer in Factorio, like in the early access days, multiplayer in Factorio would be impossible. You couldn't possibly. And then they did it. And then I realized, right, it's deterministic lockstep. All they're sending over the network is, hey, I've plopped down a foundry and these coordinates. And then, on tick, 113. And then every client that's connected is like, okay, tick 113, there's a foundry here, it's now doing stuff, and we're in perfect sequence. Don't be confused when I use the word lockstep. If you've played Path of Exile is not a deterministic lockstep. The lockstep movement is something different, similar but different for various things. The other way you can do it is a purely authoritative server situation. This is much more common if you're thinking about like a web-based game. And this is where a lot of my background comes from. Is that kind of idea. The server really does control everything and then just sends a certain amount of information to the clients, maybe not even all the information in the world, and various things. And so there's all these little hybrid in between things. There's also the concern about cheating, right? What happens if one player is running on a hack client? What kind of cheating might that be possible? We'll tell you this, the only way that can be completely prevented is with dedicated servers, right? The always online dedicated servers that we all hate. That's the only way to prevent that, because then you have a fully authoritative server, maybe also authoritarian server, that is running at, Blizzard HQ or whatever, and it handles all the game rules. And the only true copy of the game is there. When you're running on something that is, this is not actually a peer-to-peer setup. We're still going to have a server, a host that's going to work there, but it's just, you and your friends playing things. There's no way to truly prevent cheating, because while you could make it so that the host is still completely authoritative, if that host is just, Bob running his computer, there's nothing stopping Bob from hacking that to give his character superpowers. So with that in mind, especially with the simple example that we're working towards here, we're not going to be too stressed if some things are handled on the client side. And specifically, it's going to be one thing, and that is going to be character movement. Because one of the things you can do with the character movement is we could have it that the server is authoritative about where every character is in the game. And then all we're doing is sending the intent. I am saying, I would like my character to move to the left, please. And then you send that message, and then the server gets that, and then the server advances the simulation one tick, and then the server sends it back of, okay, now your character is over here. I mean, that works great, but there's latency in that turnaround. And now all of a sudden you don't have a character that's responsive. And then, okay, so what do we do about that? Well, okay, so we have our character, we predict our movement. We assume that the movement is going to be fine and legal, because we do have a relatively decent updated copy of what the world looks like. So I'm going to assume I can move to the left. So I'm going to start moving the character to the left immediately. And then when I get the response back from the server, I'm going to have to reconcile the server's image of things with mine, but the server's still behind by one cycle, because I send a message to the server, it sends a message back. So there's this whole round trip thing where what I got back from the server is this extra half step away. And how do this is a solved problem. There's the book you want to read for this is Multiplayer Game Programming, Architecting Network Games, Multiplayer Game Programming by Glazer and Medev, which I've read. It's lovely. It's wonderful. It's about 10 years old at this point, but it's like super, super ultra relevant. In fact, it might be relevant forever kind of thing. And they talk about all kinds of different ways to do this with, So prediction, reconciliation, and then we still want interpolation or extrapolation on the other clients to my predict things and the smooth movement. Because let's say, like when you think about Diablo 2, I think ran at about 20 hertz, 20 network tick updates per second. And so you don't want the other players to sort of go tick, 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 tick as they move across the screen. You want to smoothly move from one location to another at whatever native visual frame rate you're running, no matter what the network update speed was. So some of that's still going to be applied. But anyway, all that to say, for our game, we're going to have each local client control their own character's movement. The authority on the position of a player character is going to belong to the local player. It's just something we can implement super fast, and later we can replace with a more sophisticated system, 100%. But anyway, we're going to start with that. But before we do any of that, we've got to get goddamn connected to one another computer. So what we're going to do is we're going to create a new script, and we're going to call it net.cs. I'm going to create it over on this side. Actually, what I'm going to do is I think I'm going to create a new folder called networking. Why'd you put it in level? Why is nothing ending up where I want it? Yes, move it to the root. That's going to be fine. And then in here, I'm going to create a new file, and I'm going to call it net.cs. Do I want to start it blank? Actually, just to get a little bit of something, I don't think it's going to matter. We're going to create it inside of Godot after all. But I'm going to create it as project settings, globals, autoload. Now, I resisted playing with autoload for a really long time because I don't like things that are magic. I'm like, oh, stuff that's autoloaded and globals. We all know that globals are evil and singletons are evil and all these things. They tend to be anti-patterns. But they don't have to be. And in fact, with something like the thing that controls the networking in your game, that kind of is something that should only have one copy of. And in fact, if we're using Godot's networking, which we are, we're not going to be writing our own networking code from scratch. We're going to use Godot's own networking. The multiplayer object is a global singleton because it makes sense in a game like this. You just have one network connection and that is it. And also, when I used to work in Unity, I didn't like Unity's scene loading function. I really like to have a lot of direct control. A lot of times my scenes would be organized where I would have sort of the actual level, but then I would have a bunch of things just, with no parent, just on the root itself. That would be my network manager, my sound manager, my other things manager like this. And then when I would load new scenes, a lot of times I didn't load the entire scene. I mean, you could do the don't destroy unload thing, but a lot of times what I would just be replacing is like the level section in my scene, right? Which is really, in this situation, if we were to organize this, if I were to add a new node, really what I have here is level, and then that goes up here, and then ground, and dungeon structure goes under level, and level would need its Y sort enabled as well to keep that going, right? And all I would be doing is destroying this game object and loading in a new one. Really, what the autoload in Godot does is basically that. Because Unity didn't have an explicit root node in your scene, except it did. It had a sort of hidden invisible root node that everything belonged to. And the same sort of thing is actually happening behind the scenes in Godot here. There's actually almost an extra higher level that's hidden behind the scenes. And that is where the autoloaders live, because they're an actual node. I'm going to create a new script. I will call it net. And it's just going to be a node type as a base, because it doesn't need to know anything about visual. It doesn't have positions of 2D or 3D. It's just something that exists somewhere. And I think if I hit play and I go to remote, yeah, there you go. You can see there's an actual even more root node than before that's above Lobbytown. And you can see net is living next to it. That's it. That's how it actually works when it's running. This is just a node that exists in the scene. And as soon as I realized that, this entire autoload stuff stopped feeling like bullshit and started making perfect sense to me. Ah, so lovely. Anyway, this is just something that's just going to exist. It doesn't show up in the scene view over here because you don't have to tend to mess around with it. It's just going to exist. As soon as your program starts running, this is going to be ready to go. So let's go and implement this. Now, one thing I like to do is I like to build things up incrementally, right? And show things along the way. With this, we are really going to have to do a certain amount of stuff happening all at once. There's a few things we're going to need for our connections because we're going to be connecting over the network. We need to know what we're going to connect to. We are going to hardwire in, for now, a default host, which we're just going to put in as our loopback address, 127.0.0.1. We're just going to be connecting to ourselves. We're also going to need a port that this is going to operate on. So we're going to do a default port of, on computers, ports 0, well, is there a 0 port? There might be, I don't know. 1 through 1024 tend to be reserved. You need admin access and things like that. You don't want to collide with things and whatever. So we're going to assign some arbitrary number above this. It could be completely random. I'm going to randomly choose, what sounds good? Something with a bunch of 1s and 8s in it. Oh, I can't do 18, unfortunately, so let's go with 8118. I guess I could have gone 1818. That would work too, but anyway, 8118 is going to be the port we use. There's also, when we create the server side, we don't need to specify the number of connections because there is a default that's put in there. I think a default's the 32 or something like that. But, action RPGs with maybe 4 of our friends, let's say we're going to define a public const int default player limit of 4. And the reason I'm calling it default is one could imagine that later on, like we're not going to be building a UI for this, but later on when you create a game, there's going to be UI where you put in, you can maybe specify a port. You can specify how many players you want to allow, a password, other game settings, blah, 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 blah. So we'll read the default player limit from that. But for now, we're going to use the default player limit as just the limit, just what we are going to be using over here. So let's get rid of this little blank line. That's going to be okay. All right, now let's do some work in Ready. So how do I do this holistically or bit by bit? I guess, okay, let's assume we're going to have a function called host. Theoretically, this is going to be launched later by a UI button of like, create server, right? Is going to be called from some UI element. We're actually going to be calling this directly in just a moment here, but it's going to do that. And theoretically from the UI, it's going to expect a port and it's going to expect a player limit. Like that. Okay. and then we're going to start things up. So we're going to use an object called eNet multiplayer peer, called peer. A peer is someone who urinates. And every person in our game is going to be someone with a bladder, and therefore everyone in our game is a peer. Okay, peer includes the server host themselves and all the players. It is also worth noting that conceptually, you could have in a standalone server situation, right? The host, the server, might not be a player. Here, we are going to have the host is going to be a player all at the same time. Everyone's on equal footing that way, except that the clients connect to the server, and the server is going to have authority over some of the game mechanics. Not so much because we're worried about anti-cheat, because that's covered, as I mentioned, because we're not running actual company-run dedicated servers. There's no way to block cheating permanently, but we ultimately need to figure out how does the true version of the world stay in sync. And if we're not going with the lockstep networking model, the deterministic lockstep, then the easiest way to do it is just to have one of the peers designated as, okay, you hold the real shape of the world for us and make sure that everything stays in sync. And out of convenience, we're just going to have that also happen to be the server, because that just seems pretty good and what you'd expect. So we're going to do this. We're going to create a new, I can use this, right? Yes. Okay, good. I'm still so hardwired to doing, not that. Hello, autocomplete. I'm so hard-coded to do this. And then it's nice to get the little reminder, by the way, the new expression can be simplified. I don't know in what version of, C# or .NET this was introduced, but gosh, it's awfully convenient to do this. Now, it is worth noting that you could also, and I should have addressed some of this earlier, some people love to do this. And just define everything using var. And this auto fills in the C# builder, and even the IDE that we're working here, Visual Studio Code, absolutely 100% can recognize that this is an object of type eNet multiplayer peer. And you reading the code, that looks pretty straightforward. But what if instead we had some function that returns something? And if this function didn't explicitly in its name tell you what the hell is being returned here, you as a human being could not look at this line and know what peer is holding. That's why I am super opposed to using var. And in fact, what I usually do in my editor config, and even, in my editor config, I configure some rules in here that prevent me from using var. And I actually bring it all the way up to a compiler error. If I use a var somewhere, it throws an error and refuses to build, because I think it's a terrible idea. But now, so I always do this instead of var. And then as a bonus, we don't have to repeat things twice. We can just clean this. So you're making you one of those. Great, lovely, excellent, blah. Oh, hey. Randomly something on YouTube 10 minutes ago regarding a get real velocity, trying to figure out how to let a character jump realistically from slopes. Get real velocity somehow lessened. The actual angle of the slope comes to mind, but it breaks my brain. Yeah, okay. No, honestly, I've looked up the documentation 17 times this week in preparation for this video, and I honestly don't have a good grasp of describing the difference between get velocity and get real velocity. It also applies, so we're working with character body 2D, but also applies to character body 3D as well. Those two exact things absolutely exist in the same way. And I went through and looked at different examples and this and that, and I'm like, I'm not sure where you use one versus the other. I'm sorry. I think it's because I would have to test. I would have to go and make a platformer or make a typical sort of 3D running around environment and test the results of both reading velocity after a move and slide and reading the get real velocity and compare what happens if you're standing on a moving platform, if you're on a slope, and all those things. And anyway, let's get back to the host. Okay, so we've created this multiplayer peer, but this doesn't know if it's supposed to be a server or a client yet. So what we're going to do is we're going to call peer.createServer. We're going to be wrapping this in if in a second. Don't let me forget. And this needs two things. Well, it only needs one thing, which is a port, which we've got. But it also does specify maximum clients. This is how many things can be connected to it. And we are going to use our default player limit, or the player limit that we passed there, right? Player limit over here. We're going to put it here. But here's the thing. This is defining how many players can connect to us. If we're saying that our game is a 4-player game, then what we actually have is a client limit which is player limit -1. Because if we have 4-player limit, 1 is the server, and then we can have 3 clients connected to it. So in fact, we would do this in this case. Now, I think that nowhere else in our code, if we can avoid it, should we actually be looking at a player limit. I don't want to hard code the game to 4 players. Honestly, if people go through the UI and say, I want to play with 16 players, sure, who cares? As long as you get the bandwidth and the CPU and the game balance doesn't go bonkers, like, whatever. That's not this scope. Okay, so this is how we create the server, but this returns an error. Even if it succeeds. I don't know if that's named in a very good way, but this does return something, and we want to say if it's not equal to error.ok. So we're hoping that this task failed successfully, where error was okay. If it's not okay, we've got a problem, and we're going to output some information. By the way, in Godot, you might be used to outputting dummy information this way. Let me go in Ready over here. Let me do a little bit of an example, because this is actually worth talking about. Thing happened. And then we could also go gd.print error. Bad thing happened. Now, if we run this, that should run. So if I hit play, we should get a couple of things in our log. There you go. So we got thing happened and bad thing happened. And let me tell you, the formatting on bad thing happens looks great. You can't click on these. It doesn't send you into the editor. Instead, what you want is push warning or push error. And then if we go and run this, instead of showing up in the output console, it'll show up in the debugger on the errors. And you can see we got a warning and we got an error over here. And if we double click on this, it opens it up in VS Code or whatever your editor is in the right file with the right line highlighted, which is absolutely what you freaking want. There's no GD push generic info, which I guess is kind of reasonable. But yeah, if you want that sort of like trace, and it is the full stack trace, which is great and lovely and things like that. Anyway, so with that in mind, what we don't want to do, if there is a genuine error, which this could be an example of over here, if there's a genuine error, we don't want to just print to the console. We want to say gd.pushError, and we want, I guess I'll do the same way as I was doing before. Net could not host on port, and then what we need is we need a little $sign over here. There we go. That this will put in port in there for us. Could not host on port this. Could be that the user's computer doesn't have a networking card / drive or anything. Most likely, probably port 8118 is already in use, so we couldn't open a listener on that port. Whatever the case is, something real bad just happened, and we want to bail. To do where to actually redirect logic. All we're doing right now is pushing out an error and then returning, and we'll see what happens. Yeah, var just infers the type. Yeah, if you use var, and it works fine because it's still a statically coded language, like a strongly typed language is what I mean to say. So even with var, it's not just creating some sort of like variable variant type of like a variant variable that can hold any kind of data or anything like that. With var, it's still just going to be whatever it is. Like if I put a var here, client limit is going to be an integer because it figures it out. But it's just terrible from your brain point of view. Here's the thing. Think of your brain like an LLM, right? Like Claude Code or like Codex or any of those things, right? If you were working with this project in Claude Code and you were using var, Claude, or especially if it's returning from a function, and Claude wanted to know what the hell this variable type was, it would have to go and look at that function and see what that function returns, and then it would know. And that's exactly the same sort of bullshit you would have to do if you were trying to figure out that code. So save you some mental context by doing this, which compiles to exactly the same thing, but tells you, oh, it's an integer. Cool, wonderful. I mean, obviously in the IDE, you can mouse over things, get all kinds of local appropriate information, but man, oh man. You're running a typed language, use the damn types, exactly. Anyway, okay, so if we get to here, we have opened the port, which is great. The thing we have to do is the Godot multiplayer has this is our, like the static sort of singleton object. It's not an object, well, whatever. Thing, multiplayer. And we have to say multiplayer peer. We only have one. We have to tell the Godot networking system what peer is actually running for us. And so we go and save that over here. In fact, what we should probably do is we should probably have a public void assign peer. I didn't have this before, but I think we should have that. Which does this, does that. Oh, sorry, not public. This should be a private. Just a little helper. And what it should do is it should first try to close if we had one. And I guess in case it's null, we'll use the question mark dot. So if multiplayer peer was not already null, we will attempt to close any connection we already had, just in case there's something that needs to be cleaned up. And then what we're going to do is we're going to set it like so. And then in here, instead, what we're going to do is we're just going to call assign peer and do that. I think that's probably better. And then let's output GD. This is a good case for print, where we say net hosting on port as peer. So when you have a networking peer, you have an ID, and you can get to it by going multiplayer dot get unique ID. As the server, this should return 1. By convention, if you set up a server, it should auto-assign you ID 1. The client IDs are all, I don't know where they pull them out of. They're not sequential. The next person that connects isn't going to be 2. They're going to be, 300,058 or whatever. It's going to be some number, and I don't know how it assigns them, but it does. But the server, this should return 1. I guess we can probably just run that. So if I say I want to host on default port with the default player limit, this should run. Hosting on 8118 is peer 1. There we go. So we now have an open socket and we're ready to accept connections. Great. What we're going to have to do is, so we're going to make a companion to host called join. Public void join. And in this case, we're going to need to know the host address and also the port. And the join is going to work really similar to host. In fact, I'm going to go and copy all this crap. And we're just going to change a few things. So instead of create server, we're going to have it create client. And the client needs slightly different info. It needs the address, which we're just putting in as host address. And then it needs a port, and it doesn't need a client limit. There we go. And then, right, we'll just could not, and this is important. I'm not going to say could not connect. That's not what we're doing right here exactly. This is could not create client for, and then we could do something like host address :port, like that. Okay. Important. We are not connected yet. Here's the thing. So to be simple, there's effectively 2 different ways that you can connect to a device online. And really, in a way, only one of them is a connection, really. You use TCP and UDP. And TCP is super duper ultra reliable and takes care of a lot of your stuff internally. It'll be like Windows or Linux or whatever is doing a lot of stuff on the back end for you, which is in a TCP network connection. What's basically happening is Alice is trying to talk to Bob, and Alice is saying, hey, Bob, are you there? And Bob's like, yes, I'm there. Okay, Bob, I'm going to ask you a question, okay? Okay, Alice, I'm ready to receive your question. Okay, the question I'm asking you is this long, and it's, what's the temperature over there? And Bob is going to say, okay, Alice, I got your message, and it was this long, and I'm saying that the temperature over here is blah. And then Alice says, okay, Bob, I got your response about the temperature, and it's this, and it came in the right order. And then Bob's going to say, oh, good, I'm really happy that you got it. Okay, yes. It's so goddamn chatty. The other way that you can do networking, I mean, again, I'm approximating here, is using UDP. UDP is an unreliable protocol that doesn't have all this bullshit overhead. All it does is blindly fling a packet into the internet, and that's it. Alice is saying, yo, Bob, what's the temperature over there? And Alice is going to hope that a completely unrelated packet is going to suddenly arrive on her computer sometime later. Hey, Alice, this is Bob. It's 25 degrees. And Alice is going to be like, oh, this is probably related to my question earlier, or something like that. UDP that is inconsistent. It's not. There's no guarantee that the packet will arrive at its destination. There's no guarantee that the packets will arrive in the order that you sent them, because they could take slightly different branches throughout the internet, and things could arrive at the destination in a different order. But UDP is fast. It has very little overhead, and it is the reason that most games, for the majority of their stuff, if they're in action-packed games, do stuff over UDP. It's super speedy. You like my explanation of TCP versus UDP? Excellent. I'm good at metaphors. Anyway, so that's the situation here. So what's going on with the join here is we are creating this client, and we're attempting to open this local port to send a signal out. This failure is going to happen if for some reason we weren't able to even attempt to open a network connection on our own computer. We got blocked by a firewall, or there's some sort of networking configuration kerfuffleage on the computer or something like that. This create client is almost never going to fail unless there's something like horrifically wrong with the network configuration on the computer that you're at. That's what it is. This is not the connection. This is just, okay, we've sort of opened this, we've created this client. Behind the scenes, Godot's networking will be sending a message to this, on the other hand, looking to get received. And it's just going to be basically sending a hello, and it's hoping to get a hello back. And that's it. But there's no real fixed stuff. And in fact, there's some weird things that can happen. So we tested our host. Let's say we flip this around. Let's try a join. Actually, let me set up a couple of listeners first, because that'll showcase a few things. There's a few messages that multiplayer, there's a few events that we want to pay attention to. We want to pay attention to connected to server. And we want it, when connected to server, when that signal gets emitted by the multiplayer, we want it to call a function that we're going to write in a second called on connected to server. And then we're going to do the same thing for, I did not copy before I pasted. There we go. We are going to look for connection failed and server disconnected. So on connection failed and on server disconnected. Let's get that lined up nicely. Then let's go and write these functions. And in the interest of time, I'm going to do a very quick copy and paste, because there is really nothing to do here. And actually, I'm going to have to remove a couple of return to offlines, because we don't have that yet. Okay, so we're just going to have these functions are going to get called when those messages happen. And then, so what we're going to do is over here, let's wire the connection, the listeners first. And then let's attempt to connect. So we're going to go join. It'll be default host on the default port, and we don't have to send a player limit. We're just going to try to join. Now, obviously, there's going to be no server listening, because we don't have a server up. So we're going to attempt to connect to a server that doesn't exist. We'll hit play. Why does it say hosting? Oh, because I didn't actually update my little message. What I want actually to say this, connecting to, there we go. Try that again. Hit play. Connecting to this. And then we're going to wait. And we're going to wait 30 seconds. And only at that point is Godot going to give up. Because what it's doing is sending the hello packet. And it didn't get a response right away. But, you know, it can get lost over the internet. So it's going to send another hello packet. And another one. And another one. I don't know how quickly it sends it. I don't know if it's got some sort of like, what do you call it? Not standoff. Walk back. I don't know. Where it's like, okay, I'll send one a second, then another second will go, and then I'll wait 2 seconds, then 4, then this, back off kind of thing. There you go. Finally, connection failed. Eventually, after, I don't know, maybe 30 seconds, eventually Godot was like, yep, all right, it's not going to work out. I haven't connected. Even though it's on the same machine, right? This should be instant. If this was a TCP connection, it would be instant that we're sending a packet to a TCP port on this machine, and the machine is like, well, that TCP port isn't open, and it would immediately send back a failed, but that doesn't happen on UDP. So we just have to remember that join, we are not connected yet. We're just trying to connect. It won't happen until we get to unconnected server, which can't happen right now because the server ain't listening. So what we want to do is we want to open both sides of this. What we're going to do is I'm going to create a little helper script over here, which I'm going to call, where is it? I don't want to write this live because it's going to be, I mean, it's trivially short to write, but it's also not very interesting to see. I have a little command line processing script. So I'm going to call this command lines, boom. And I'm just going to copy, and paste. All right. So this is just a little piece of code that all it does is going to parse command line things. I'm going to run this game with -- server, and that instance is going to run as a server. And I'm also going to run one as -- client, and that instance is going to run as a client. I'm not even going to go and read like command line parameters. I'm not going to get a host name or a port or anything like that. I'm just looking for those two flags. This is just going to do the work of parsing that for us. So we're going to flip back over to net.cs, and we are going to run in ready over here. Instead of joining, we're going to run process command line. And this is going to be a private void command line. And it's just going to check. I'm having some apple vanilla tea, which is really nice, although it has gotten cold, which is less than ideal, but it's still very nice. There we go. Okay. So in here, we're going to have a Boolean of wants to be server, which is true if command line dot has flag server, like that. And then we're going to say, we're going to do the same thing for wants to be client, except it's with client. There we go. And the reason I check for both is because if someone passes both, that's probably bad. So if wants to be client and wants to be server, then, I mean, we definitely want to like bail and return gd.push error. Can't be both server and client, dummy. There we are. Okay, so we're going to bail on that. And then we're just going to say if wants to be server, then we are going to run host. And we're just going to blindly feed the host. Again, the default port and default player limit. We could read those from the command line. Then we're going to do an else if, wants to be client. Then we do join default host default port. Else, offline mode. We'll be right back to that thing in just a second. Offline mode is going to work perfectly well. Okay, so we've got those two, and we process command line. So now all we have to do is feed those parameters in there. Because if we get to here, hang on, we do gd.print offline mode to do. So if I were to just hit play right now, we should get the offline mode to do, assuming I've done everything right and actually called the functions. Number one cause of things not working for me is forgetting to call a function in the first place. Load server client, we could absolutely do that as well. Well, it didn't happen. Do I not call process command line? Because I'm not passing any flags right now. Oh, file wasn't saved? Thank you. I thought, what the hell? I mean, it's easy to make mistakes, but I felt pretty confident about that. There we go. Offline mode to do. We don't have an offline mode yet. All right. So how are we going to run this? Well, we could do a build, and I could go into the command line and run it from there. Here's what we're going to do. Debug, customize run instances. Boop. Enable multiple instances. I would like to run 2 copies of this game, please. I would like the first copy to have the -- server command line argument. And then the second one, I would like to have -- client one. Cool. I like Godot. All right. Now I have 2 instances of the game running. Here and here. And because of the order it is, and I know that's one of the reasons I did the embedding here, I know for sure this one here ran first, and this one here is the server, and this one here is the client. And then if we take a look at our code, in fact, let's close, let's shut all this down. It's going to be fine. What do we see here? So the messages can arrive in a slightly different order, but so we had one instance over here hosting on 8118 as peer 1 on connected to server, ran from the client. Yeah, so I mean, these messages are all mushed together in one output, but we can see one is connecting, one is hosting. And here's the thing, even if the client started first, the first connection attempt it sent might hit a server that's not running yet. But then again, after a second or whatever Godot's internal things are, it'll send another one and then connect it. But it's working. It's working. We have a server and we have a client, and the client connects to the server. Gorgeous, lovely. And then you can always toggle back and forth. Let's do this offline mode because that is going to be super duper handy, because that's the question. Okay, so we have all these online mechanics. What happens if a player wants to play all on their own? How do we make that work? Well, really, the client could just host themselves with a player limited one. That'd be fine. The issue with that is it still tries to open a port that, doesn't really listen, would trigger, the sort of Windows pop-up of, hey, this game wants to open a port. Are you cool with that? Like, what's your vibe with it? What we're going to have is we're going to have an offline mode. Public void offline mode. And it is still going to go and create a multiplayer peer, but it's not going to create an eNet multiplayer peer. It's going to create an offline multiplayer peer that otherwise works exactly the same. Peer equals new. And then we're going to assign peer, and then we're going to do a, where are you? Because assign peer expects this specifically. What is the parent of this? Is it just multiplayer peer? There he goes. Okay, there you go. Now this accepts any kind of multiplayer peer, eNet or offline, and then sets it. That's good. Okay. We do that, and then we do a gd.print. And we just say net self-hosting in offline mode. And the thing is, this is going to set up all the networking plumbing in exactly the same way as if we were running a proper server and client, except it's just going to be an immediate loopback. It's just going to be in memory. It's just going to be a little shim layer in there to make it so that we're going to write everything else in our game as if we were networked and multiplayer and all these things were happening. But when you're playing online, or when you're playing on your own offline, it's not going to touch a socket. There's going to be 0 latency because it's just going to be this in-memory loop. So we're in offline mode over here. I guess we still have to say offline to do actually. So I'm forgetting to do is call offline mode. There you go. Not calling a function. That's good. And then what I'm going to do over here for these offline modes is if the connection fails, I'm just going to put us in offline mode. And if we get disconnected to the server, we're just going to go into offline mode. We should probably like reload the scene or something like that. Let's not worry about it. Just in a case of a failure, we're just going to loop back to going into offline mode. But otherwise, we're just going to chooch from there and pretend everything is working okay. All right. Perhaps velocity and real velocity differ by frame reference. It's possible that's the biggest difference. Yeah, I'm not sure. Sorry, I didn't see that earlier. Didn't respond to it earlier. It was in the mode. Hey, JS Moore. Nice to see you. You must connect to a server to play offline. Yes, of course. It's SimCity. It's all these things. And then, when the servers go offline, then no one can play the games anymore. And that's fine. That's normal, right? Everyone's accepted that that's how things work. Okay. So if we go back to our little planning document, right, we've now finished initialize the network. We now have to do two other things, spawn in players in a multiplayer fashion. Because what happens right now is if I go back to customize run instances and we run this, yes, they're connected. But other than that, everything is just running on each local machine, right? This socket exists, but 0% of anything is being transferred on it. And that includes our little player character, who just each peer, server and client, has one copy of the player character, and that's it. We got to change it. We got to make it so the player character doesn't start off in the world as a single object here. We got to spawn it in based on every connection. So step one, we're going to turn this player character into its own scene. If you're coming from the Unity world, we're making a prefab. In Godot, everything is a scene because honestly, it works better. So we're not going to be in level. We're going to be in character, and I'll just put player character, the prefab on the root over there. There we go. So it's there. We can edit it by going here or by just finding it over here. And then we can open the player character scene and do some work over there. That's great. Then we're going to get rid of the player character from our game. And instead, we're going to create a couple of little objects in here. The first thing we need to do is we need to create an object that is going to be where our players get spawned to. Well, okay, let me back up a little bit. What we're really doing first is we're creating a multiplayer spawner. Multiplayer spawner's job is when a new node gets instantiated and added to the scene, not actually uninstantiated, it's when it gets added to the scene from a prefab, from a scene, from a packed scene, right? Like in this case, it's going to be player underscore character. When player underscore character gets instantiated and added to the scene by presumably the server, multiplayer spawner is listening for this and will send that to every connected peer so that it happens everywhere in exactly the same way. This is not going to synchronize movement or anything yet. It's just going to ensure that there's a copy of this object that gets spawned on every single connected peer. That's the goal of multiplayer spawner. Now, there's a variety of different ways that you can make this work. There is this auto spawn list. And what you can do is if you go and slap a prefab in there, so add element and then slap a prefab in there. There you go. And then if we go and instantiate a copy of player character scene, this should automatically pick it up and send it to every peer in there with a little bit of extra stuff that we're going to do along the way. Now it needs to know where to go and instantiate that. So I'm going to go and I will create, and this can be anything, but no, not a child scene. I'm going to add a child node, probably a node 2D. It might not matter, actually. But anyway, let's call this, what do they call it in the thing, just so I keep the name consistent? They call it the spawn path. I'll call it player spawn path. And then in multiplayer spawner, we just go and do that. So there we go. So when this object gets spawned, it's going to show up in here. Well, that's actually not the response to a multiplayer spawner. So it's a little bit weird. What happens is when a object gets added to a scene, the multiplayer spawners check to see if that object is something in its list and the direct parent of that object is the spawn path. And it also checks to make sure that the thing that instantiated, or rather added that object to the scene, is the multiplayer authority for that multiplayer spawner. Anyway, if all those things are true, then multiplayer spawner packages up a network signal that sends to all the peers to say, hey, you should also create a copy of this object here. The only information that multiplayer spawner has is which prefab it is. And it doesn't actually send the entire, it doesn't send the scene. It doesn't send the prefab. It doesn't send the prefab itself, doesn't send its name, doesn't send anything like that. All it does is send the ID. It says, okay, element 0, because the 0th is the first element on our list, should be created. And the only other thing it sends is the name. Hey, new subscriber. FMJNax, thanks for the sub. The only other thing it sends is the name of that object in the tree. That's it. That's all. No other extra information. Every other piece of information is something that multiplayer synchronizer is going to have to take care of for us. Okay, but let's go and see if we can get 2 characters to spawn in there. Now you can do a lot of this with script. There is a code. So do I still need, hold on.
Hey Quill, pay attention.
Yeah, I'm going to need, I'm still going to need a script on this. So we're going to go and do this. I'm going to call this, I'm going to rename this whole object. So your multiplayer spawner could have another subscriber. The Shock, thank you very much. Remember, you can join the Discord as well. If you're a subscriber on Twitch, YouTube member, or a Patreon supporter. Right, the multiplayer spawner can have a whole bunch of different things that it spawns there. And you can also have multiple multiplayer spawners in the game, and they can each have their own individual spawn paths as well. Ooh, my God, Flies with Wind, thank you very much for subbing as well. As people remembering their Prime subs too, that's excellent. We're going to call this player spawner, and we're going to attach a script to it. And I'm going to go... Yeah, we've got a networking folder. Great. We're going to put player spawner in there. Excellent. Man, I should have gone faster earlier so that it'd be done by now. So this is going to be the thing responsible for actually spawning the player when someone connects to the server. So first thing we're going to need a public packed scene. That's what the scene file is. And this is going to be the player character scene. And I don't think we don't need to get and set for this because it's going to be fine because it's already public. That's going to be okay. We can always change it later if we need to do some stuff. We want this to be exported so that we can drag the player scene in there. Of course, we could always set this by loading it in, referring to a UUID, all kinds of different things. But I think I'll just do this for here. That's going to be fine. We need a spawn root, but we can get that from our object as we go. No, I do need the spawn path, actually. Well, no, I must be able to read it from multiplayer spawner. So here's the thing. Okay, I'm adding this script to multiplayer spawner. It doesn't actually have to be here. I wonder if it almost would be better as an example. I'm going to leave this called multiplayer spawner. I'm going to create a different node, which is just going to be a node because it's just going to be a programming thing. And this is going to be the player spawner, just to show that the logic is not at all related. And then from multiplayer spawner, I'm going to remove its script completely. There you go. I think this is fine. Probably it's fine. The reason I was doing the script, so, okay. Originally, when I did this tutorial the first time, I didn't use the auto spawn list. You can go and instead manually do custom spawns, which is really powerful if you do want to send more than just the name. Because again, I said the only thing multiplayer spawner sends on the network is the index of the scene we're generating, and then the name of the node we're adding to the scene, and that's all. All the other information has to be synchronized externally, maybe through multiplayer synchronizer or something like that. You can write your own custom spawning code in here by overriding stuff. It's really weird. It needs what I feel is like a lot of magic formulas with the code you have to run, and it's like this whole chain of multiple sequences of functions that get called directly or indirectly. There's sort of implied RPCs, and I decided, you know what, maybe we're not going to do it that way. So to really emphasize that point, I'm not going to put the script on here, but there's sort of no reason that it can't be on there. Instead, what I'm going to do is going to put the script here. I'm just going to change this to be something that derives from node, player spawner, and then I'm just going to attach the player spawner here. Hopefully, this isn't going to cause me issues, because that can happen when you change your mind about things. Oh, also, net can be moved into networking. That's where I want that to be, please. Thank you. And then I think I want a sort of a common or utility. Ooh, whiskey and chocolate.
Quill Programs is back.
Hang on 1 second. There you go. Move the command line stuff into common. There we are. So we got characters, common stuff, level stuff, networking stuff. That's a good organization. Who was that with the whiskey and chocolate? Artemis! Hey! I know it has been a while since we've done programming content. Thank you very much. Thank you so much. Okay. Oh, did I have a typo somewhere? Did it already get fixed? Oh, multiplayer scene. There you go. Thank you very much. Okay. And then we'll also need a public node 2D for player. What do I call that one? Player spawn path. Excellent. Player spawn path. And we'll make sure it's got an export on there. Export's kind of funny because you can make this a private. And the export will still make this something that's somewhat exposed. Because what it does with the export is it creates some extra get and set functions that allow Godot to get and set information about it. It's required if you want anything to show up in the inspector. It's also required for the multiplayer stuff we're going to do. When we get the multiplayer synchronizer, it has to be something that is exported and accessible that way. And weirdly, that has nothing to do with whether something is public or private. So player spawn path here would not be accessible from outside the class in my code because it's private, even though it can be accessed by Godot. Now, as it turns out, if you know what special get and set functions the export is actually creating behind the scenes, your other classes, could absolutely go and access this in various ways. But honestly, probably making these both private is fine because I don't think anything outside of this class needs to access it except for in the editor. So sure. Anyway. Okay. That's good. So, okay, if you did want to go, if you were writing this as a script that was inheriting from a multiplayer spawner, and if you wanted to go and add to this list here, this auto spawn list, if you want to add to it programmatically, you can do that via add spawnable scene, and you pass it a player scene. This doesn't work because this is not being inherited from that, but that would absolutely be a thing. So you can add it programmatically. The gotcha here is that because when the way the multiplayer spawner works is it sends just the index. It's saying we're instantiating object 18 in this list. It's critical that every computer, so both server and every single client, every peer, that list has to be in exactly the same order. They have to be identical on both. On all systems, which if you're just sending it through the editor here, because it's just baked into the game, it will be. If you're writing in a code like this, if there's anything that could cause this code to like execute in slightly different orders or whatever, because if you've got multiple pieces of code that are adding to this add spawnable scenes and they might run in a slightly different order, that could go and break things. Probably it's not an issue, but technically that's something that could be a thing. Anyway, what we need to do, well, first of all, this should only run if we're the server. So if we are not the multiplayer dot is server, then we can just bail, right? Because what we're about to do here only runs on the server. The server is going to be responsible for spawning player copies. The non-server clients, if they try to create player copies, they will create a player copy, but it's only going to exist on their computer because they don't have the authority to send things via the multiplayer spawner. And in any case, it would be a stupid, horrible thing to do. We only want the server to do this. And then we need to listen to a couple of things. So multiplayer dot, when a peer connects to us, we want to call a function that we're about to write called onPeerConnected. And likewise, to do some cleanup, is when a peer gets disconnected, then we are going to call onPeerDisconnected. Like that. And you know what? Let's make this pretty and line that up over there. To do, don't forget the host player. We'll be back on that in a second. We do not need a process function on this at all. All right, let's write these two listeners. So we're going to do a public void, boom. This is going to pass us a long peer ID. So when a peer connects to us, we are going to get the ID of that peer. And I have no idea why Godot decided to do this, but they send this to us as a long, which is a 64-bit integer. Despite the fact that in the documentation, this is by definition always going to be within a 32-bit space. If we did an int here, then we would get a mismatch because the signature doesn't match. But what's weird, and this mostly came up when I was doing the version where I was spawning, I was doing a custom spawn function to spawn things instead of using the auto list. A bunch of the stuff there needs an integer, not the long. So you end up at some point, you have to cast from the long to the integer. So like half the Godot multiplayer code is like written for the 64-bit integer and the other half is written for a 32-bit integer, which is fine because the 32-bit one never or the 64-bit one never uses more than 32 bits in the first place, so you can safely cast. It's just a little strange. I'm assuming there's some effort at future proofing there, but it's a little bizarre. Anyway, all we're gonna do over here is we're gonna call another function. Spawn player for, and we're just gonna pass a peer ID. We could do the work in here, but I feel very strongly that functions should do what their name says it does. And onPeerConnected doesn't say anything about what it does. It only says when it's getting called, basically. This is a function that gets called when a peer connects to us. Let's go and then forward the job to a thing that's actually got a reasonable name, which is spawn player. Spawn player, there we go. Okay. I guess these don't have to be public, actually. These should be private. And whoops, I keep clicking that reference link when I want to do this. And then we're gonna have another one, which is going to be spawn player for long peer ID. And this is going to do, it's going to have 3 lines, basically. Well, to do check if already exists. I don't know if we can end up in a situation where a peer lingers around for some reason. I suppose we could, if we wrote code where if a player disconnects, then we keep their character around for up to 30 seconds in the world for whatever reason, then maybe that would be important. I don't think it's going to be. So what we're gonna do here is we're instantiating a new player. So we're doing it's gonna be a new node 2D. I mean, technically what we're actually instantiating is something that's a character body 2D, but character body 2D descends from node 2Ds, and it doesn't matter. It's going to be fine. So we're going to have a new player, and we're going to do our player character scene. We are going to instantiate it. I don't know. It's like that, because all we're doing is this. We're not interacting with anything that's the character body 2D, so I think this is fine. I guess we'll find out. And we're going to set a name, because the name of the object is the only thing about this player that's going to be sent over to the wire at this time. And the convention is to just name this based on the ID of the peer. So there's going to be an object in our scene labeled, 1, 2, 3, 4, 5, 6, which is just the ID of that player. And then we can use that to get things back. It's convenient because it gets passed on there. We don't have to tack on any extra metadata to get that assigned. It looks a little weird. Like I'd almost prefer it to be named something else. And we could name it something like character for peer and then have the number. And then on the other side, we can, split the string apart and read it and whatever, but we'll just name it directly after that. And then, I guess we'll also want a position to spawn things in. So let's do that. Where in the world do we going to spawn this player character? Because right now they would spawn at the 0, 0 point, which would be outside the room, which is no good. So we're going to create a little marker in the scene for where the characters should appear. And I will literally add in a marker 2D. Marker 2D is just a node 2D with slightly different art. I don't know if I can, okay, good, I can drag it. It's just got this little like cross wedge. Makes it a little easier to see. That's all it is. And we're just going to use it as place of, that's where we want our players to spawn. So player spawn spot. I'm going to grab this. I'm going to go into here. I'm going to specify that I want a private marker 2D called player spawn spot. We'll do an export on there. Why are you cranky? Oh. Maybe we do that. Because we're not done yet. There's a little bit more to do here. But I need it to compile so that my player spawner's got the field. Okay, so we want to say the spawn path and the spawn spot. I mean, in a sense, I could make the spawn spot the owner of this, but in practice, we'll probably end up having multiple spawn spots. Imagine, we have a huge array of them, picks one that's empty. I don't know what we need. You need the long data type for the first M and MMORPG. Yeah, that makes a lot of sense. So anyway, well, we'll have this. And, it's probably good to have these differentiated for exactly what they do. So now we're going to go player dot position is equal to player spawn spot dot position. To do fix collision. What's going to happen here when the players spawn? They're going to be spawned right on top of another. And their physics may not appreciate that. We'll deal with that in a second. And then the final thing we have to do is actually add it to the scene. Because instantiating the object doesn't add it to the scene. We are going to go with player. Oh, no, sorry, not that. We're going with player spawn spot path dot add child player. And assuming I understand everything correctly, at this point, multiplayer spawner should notice and inform the clients. Something like that. There we go. There you go. So when this runs, what should happen is multiplayer spawner should send a signal to all other computers and tell them to go and spawn a copy of the player prefab with a particular name in the tree. It does not get the information about the position. And actually, that'll be interesting because we're going to test this before we have a synchronizer. So what should happen is on the server, the clients should appear at the spawn spot. On the client, they should appear at the origin in the corner. That's actually very interesting to me. I guess I can run this? Oh, I guess we could do the despawn player at the same time, just for so that I don't forget it later on. We are going to have a private void despawn player for long peer ID. And this is just going to be, we are going to look at the player spawn path, and then we're going to get a node in it. We'll go with get node or null, just in case for some reason it was already deleted. It won't throw an exception. PID.toString, because that's what the node is called. And then, assuming it's not null, so question mark dot, we are going to queue free to delete it. And this multiplayer spawner should also go and respawn here. When the server deletes a copy of an object, the multiplayer spawner should go and send that signal to the other clients as well, if it was something that was like successfully spawned through this system. So then we just call despawn player 4. Okay, let's see if this works, with the caveat that the position definitely won't be right. Okay. Oh, nope, we got an error. Null. Did I? Oh, I never actually assigned the player prefab. Or I did, and then maybe when I moved the code, I don't remember. Okay. We can't see it, but in theory, there is a player way out there. Or in fact, 2. Let's find out. Okay, I'm going to do a lazy quick little thing here. I'm going to add a camera 2D. And the camera 2D just centers the camera view where it's located. So I'm just going to put it sort of here. So if I do this, we should get a kind of an offset camera. There we go. Perfect. Excellent. So this is exactly what I was hoping for. On the server, there should be 2 copies over here. If I go to remote lobby town, player spawn spot path, no, there's only 1 because I'm only spawning a copy for the player right now. Let's fix that actually before we do anything else. Because remember here, I said, don't forget the host player. This is the other reason for having functions that are actually not where we don't put the logic inside the listener. It's because one of the things we want to do is for the host player is we want to spawn a player for ourselves. The host player always has ID 1, but we're not going to assume that. We're going to say get unique ID. There you go. So now there should be 2 instances of the player in the game. All right, on the client, they've just gone and warped into space. That's because they're colliding with each other. Actually, on both sides, I think that might be what's happening. Yeah. I think everything's gone and warped out into space. Yeah, you can see the position over here is just being shoved to infinity and beyond. I suppose we want different spawn spots so that they don't spawn overlapped and yada, yada, yada. I think what I'm going to do in my player character, in the collision state 2D, in the where's the collision layer? Oh, hold on. Is it part of this? It's part of this. No. Motion mode should technically be floating. I don't know that matters. What am I? Oh, no, that's the platforms. How to be under collision? Is it here? Oh, here we go. If I turn off the mask or the layer, oh, I should do 2 different layers is what I should do. Yeah, layer 1 is going to be world. Layer 2 is going to be players. And then with that? No, almost don't want the opposite. What do I want? Do I want to say the player exists on layer 2 and collides with layer 1? Is that what the mask is? Yes. There we go. Okay. The players no longer collide with one another, but they still collide with the world. You'll notice that our problem is happening here again with our player head is behind things. The reason is the players, stop this, the players are children of player spawn path over here. Player spawn path has to be told to do the Y sorting. Okay, good. So the players no longer collide with each other, so they no longer warp into infinity. If we do want to turn collision on with them again, we could. If all we did, as long as we didn't spawn them in literally the same position, if we added any randomness to their position, they'd sort of shove apart. Or we'd put in some sort of like little spawning thing where each player spawns, an extra tile over to the right or something like that to do this. But for now, we'll just turn off their mutual collision, so that they don't bump into each other, and that's fine. Okay, but a couple more things going on. Even though. So what should happen? Oh, and we didn't verify this. Or did we? Maybe I did verify this. What should be happening here in remote? Yeah, there's 2 players. ID 1, that's the server. Big ID, that's the client. And then if I close this, the server, there we go, deletes the client copy of the player. That's great. The issue though is right now, if I move, and whether I'm on the client or the server, it doesn't matter. Here's on the server. And, oh, there we go. They got a slightly different animation. If I try to move right now, I'm moving both player characters at the same time, which makes perfect sense, even though in theory, we have 1 player for each, or 1 character for each player. The way they move is player input over here runs for everyone. What we need to do is know who owns this object and whether or not that is us. And if it is not us, we should not go and deal with our inputs. But actually, even before we get to that point, one of the things we should consider is who moves the object. And I think that's really what we're looking at here. And we talked about, we could do like server authoritative movement, and it's probably better overall, but we're going to require us to put in a lot of like predictive movement, reconciliation, different things like that, which we're going to avoid. We're simply going to put in a rule. First of all, only one thing should ever move the player characters. That's for sure. Only one thing should ever move the player characters. And normally that would be the server. So normally we might do something like if not multiplayer dot is server, right? Then we would return. And in fact, what we probably want to do in character mode, we probably actually just want to turn off calling physics process at all if we're not the server. We got that. But that's not what we're doing here. Instead, the only person who should be moving this is the person who owns this object. So we should go and check to see who owns this object. We are nearing the end of what we're doing today. Only an hour off so far, which isn't bad. Synchronizing movement is next. Okay. What am I looking for here? I'm looking for my reference code. Oh yes, I had previously called it combatant. That's why. What we need in here is a helper function. We might end up making it public. I don't know. I don't know. That is just a Boolean is owner. Do we own this object? And we're going to take a very naive approach here, where we're going to use the name of the object. So we're going to use long. Well, honestly, we can just go int here, but I guess we should go long. Sure. Here, ID, which is going to be based on our name. So our name dot, well, I guess what we want is long dot parse. Try parse. Parse would throw an exception. Try parse, we send that as an out and we do a check. Honestly, I'm kind of happy with just throwing an exception, to be honest. Here, we'll just do this. Long parse name. All right, so this is going to parse the name of this object and try to parse it back into a long. And then we're going to say, we're going to return simply, is the peer ID equal? No, we do have to check for proper ownership and shit. Well, okay, this will work because right now the only thing using character motors are the players. When we get to monsters and stuff, we're going to have an owner ID property on here that we set appropriately that is then going to return stuff, but we can just use the name. Then we just compare it against ourselves. Multiplayer.getUniqueID. See, there's an example. GetUniqueID is actually an int, not a long. So I guess in this case, we'd be like, all right, we'll just do it with an int. So this only works well. The only things using character motor are player characters. Once we add in proper server-owned stuff, i.e. monsters, this needs to change. But this should work for what we're trying to accomplish right now. Probably, maybe, I don't know. Okay, so what we're just going to say is, in the physics process, we're going to say if not is owner, then we return. So now what should happen is, and really we do the exact same thing in player input because we don't want to be setting the velocity and various things like that. Yeah, that is true. Okay, you know what I'm going to do? I'm going to make this public. And then in player input, we can do if this dot is owner, if not, then return. And you may be thinking, hey, why are you putting those braces there when you're just doing a one-liner? Shut up. No, I think this is much safer. One of the issues, if you do something like this, then later, then you're like, oh yeah, and also GD print, foo. Then what's happening here? Because this is in Python. Indentation is not isn't part of our logic. What's going to happen is if it's not character motor, it's going to print foo. And in all cases, it's going to run return because this is functionally identical to this. So I think, and in fact, I actually enforce this with my linter rules. I always require the braces so that it's not an issue. Okay, I wanted to do this because I didn't want the velocity. Oh, I forgot that doesn't actually modify velocity. So this actually would have been fine because we'd be setting move direction, but we'd never be using it. But yeah, just for the sake of somewhat more cleanliness, we're going to go and put that in. Okay, so what should happen now is now we should only be moving one character at a time. So in the client, I'm only moving one character. They're still not synchronized. And on the server, I'm only moving one character. Okay, that's good. All that's left, it's trivial, is getting the positions to be synced. And to do that, we're going to add in a multiplayer synchronizer. So this is the thing that's actually responsible for synchronizing some property over the network. And I'm going to call this one position sync. This is going to change a little bit. If we continue this tutorial series, this is going to change in a variety of different ways. Because right now, remember, we're taking a very naive approach where each client controls their own movement. So the owner of position sync is going to be the local client over here. It's going to have the authority over position sync, which we're going to have to set, because I think if you don't do anything, it just defaults to the server. So the server would have authority over this, which would only make sense for its own character. Although in theory, if I ran the game, I think it would semi-work. Anyway, let's add a property sync. So with position sync selected, multiplayer synchronizer, we're going to add a property sync, and we're going to do on the player character, we're going to sync the property of position. It's going to sync on spawn. So as soon as it spawns in, we're going to do a one-time sync on that. And then we've got this interesting property of how it replicates, when it replicates. Never, just turns it off. Always will update this position every single network frame, or I usually avoid the use of the word frame when I'm talking about the network packets. I think it'd be more network tick is usually more what I think about. So with every network update, with every network tick, this will always send the position. Whereas on a change only sends it if it changes. And you may be thinking, well, why would I send it if it hasn't changed? Which is an excellent, excellent idea. The difference is with on change, it sends it reliably. It guarantees that it gets there, and it gets the extra overhead. It doesn't do it via TCP. It does it via internal stuff on UDP still, but it has extra overhead on there. This is great if it is something that legitimately does not change constantly. And there are going to be times, I suppose, when a player character might be standing still. But most of the time in a game like this, the player is going to be moving constantly. And so it makes more sense to say always. But what is always? How often is always? By default, in Godot, the multiplayer system does a poll, which is both reading and processing incoming stuff, and as well as sending out pending output. Okay, as one action. It does it as a single action called poll. It does it once every visual frame of your game, which is a ridiculous amount of overkill. Now, depending on what kind of game you're doing, let's say you're doing something let's say you're doing Civilization, right? Strategy game like this. The updates happen very infrequently, right? When does an update happen in Civ? Well, when I move one unit from one tile to another, or in a city, I've gone and queued up a granary. That's it. Happens very little. And weirdly, that actually might be a good case for letting the poll happen on every single visual frame. But the flip side is you would have almost nothing that would be replicating this way with always. And in fact, almost everything you'd be doing would be via RPCs, remote procedure calls. I think that's what it stands for. And so, and those would queue up some remote function call basically, and you would want the polling to happen almost immediately. So as soon as you generate an RPC call, it gets sent out and it gets processed as quickly as possible, right? Because it's very low volume. However, it's a game where there are constant updates. You want to figure out how often your network updates should happen. Now, one thing you can do is you can use these intervals over here for replication and for delta. And these are built-in delays. So if you're letting the Godot default system to run its poll every single frame update, but you don't want to have this send literally every visual update, you can put in a little delay. We could be like, listen, only send this once every 10th of a second. Or something like that. That is entirely possible. You can use those. Replication interval is for always, and delta interval is for on change. For most action-oriented games, you really want to go and think the other way around. You want to think, okay, a lot of our stuff is going to send on every network tick, and we want to figure out how often those network ticks should go. And do we want those network updates to be synchronized with the simulation, with the physics ticks of the game? And I think for our game, the answer is absolutely that's what we want. Ideally, what we want is right before a physics tick gets processed, we run poll, make sure we've processed everything that's supposed to come in, then the server will go and simulate all the physics in a consistent thing. What we don't want is for the server to be halfway through handling a bunch of physics and we get an update or some weird thing like this. We want to avoid situations where there's like 2 updates, then a physics tick, then another physics tick, then one update, then a physics tick. Like, we don't want them to be out of sync. We really want them to be locked in. And I'm also going to propose that the nature of our game probably means we don't have to run that at 60 times a second, because the physics system in Godot, well, also in Unity, defaults to 60 frames per second, or 50 ticks, 50 updates per second. I propose that really, we could probably be like, I don't know, 30? Shit, Diablo 2, I think, runs at 20. So 30 already, we've got, more fidelity than that. This might become more important for us to then go and implement some physics interpolation for some smoothing and visual stuff like that. We could probably leave it at 60 as long as the amount of data we're sending is pretty small. 60 is probably also fine, but let's say we go ahead and do this. Doesn't that interval mean there will be inevitable delays? Yes, but that's inevitable. That no matter what we do, right? There's always network latency, no matter what happens. So there's always going to be some delay, and we have to figure out how to do it. We're sidestepping that with our local character movement by having each local client have authoritative control over their character's movement. So their character's movement will be instantly snappy without us having to worry about doing reconciliation when we get the true updates from the server, maybe rubber banding effects or different things like that or whatever. But yeah, when you're working a multiplayer game, there's always going to be some delay, and no two players are going to see the exact state of the world at the exact time. I'm going to see it one way. Bob, who's the server, is going to see it another way, and Alice, who's another player, is going to see it in a slightly different version of the world. How much is that going to split apart depends on the nature of the game, how fast things are moving, and this and this and this. I don't think it's going to be a fast enough game to worry about it, but yeah, there will be a few pixel difference on the screen between what different players see, and we're going to have to keep that in mind. And especially if we go to server authoritative movement, then we're going to have extra layers of coverage in there. Anyway, I have a question for you. How did you deal with failing your 20s? You failed something. 23, second year bachelor, just failed an exam that delayed my CS bachelor for a whole year. Eating myself to stand out and just reaching out. Thank you for the advice. Okay. That's rough. And dealing with that stuff is really, really hard. And it's okay if it feels really, really hard. But it's not, and it sucks to say it's not the end of the world, but it's not. And hopefully you've got some people in your lives to help with that. The thing is, everyone who tries anything is going to fail some things. I mean, shit, if you've watched any of my videos, you've seen me fail a lot of things a lot of the times, and it's rough. And in a sense, I'm kind of where you are because I did not successfully finish university. I like to tell the story that it's because I got a job, and I did get a job, and then I got another job and another job and another job. But I was having a genuinely very difficult time after my third year of university. If I hadn't gone and managed to get a job into another job, it would have been tricky to go back because I would have had to. I had issues with calculus. To be fair, my calculus went from being my favorite subject ever in high school and into the first 2 years of university to being my most hated subject in year 3 university. And I think I had some really, really terrible professors. There's concepts in that third year of calculus that I didn't get at the time that I got later, just randomly reading some shit on the internet. So, there's lots of reasons why the failures can happen. And you gotta, I don't know, the faster you fail, the faster you correct mistakes. That's good, yeah. That's a really good way to say it, Real Luckless. Because failure will happen, and it's just part of the process. Arguably, if you never fail, it means you haven't tried enough, right? You haven't pushed your limit. But man, I don't know. Where were we over here? That was a good question, though. All right, the network syncing. Okay, so what I'm going to propose that we want for this game is we want to disable Godot's default polling, and we want to poll ourselves in a very intentional manner. So over in a net script, right, this is our autoload thing that runs automatically at the start of the game. Now, whether it should run here, well, first of all, this process command line stuff most likely is not what we want to call. We're going to want a user interface that calls, host and offline mode and all those things, blah, 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 blah. But I think in no matter what case, what we want to do is we want to say, hey, multiplayer, Godot multiplayer, polling, false. Oh, is that a function? What's it saying about group? Is this not how I said it? Method user polling. I don't need to worry about this. Oh, it is a function. Yes, method group. Oh! Poll is a function I'm going to be calling in a second. I'm going to be calling polling in just 1 second. To turn it off, I need... Oh, yeah, that's right. I hate this. Get tree dot multiplayer polling equals false. Why? I don't know. I don't know. I don't know. Anyway, that turns off the Godot automated polling, and then we're going to poll on our own schedule. And we're going to do that inside of net. We're going to say, okay, we want to poll on pace with the physics process. So we're going to implement our own physics process here. And we are simply going to call multiplayer.poll. So we're going to poll one time per physics tick, not one time per visual frame. So already we're a little bit better off because we're going to be syncing that. But here's the thing. What order does physics process get run into? Let's say we've got 4 players, we've got 100 monsters, we got all these things. They all have a physics process. And we would like this to happen before the physics process runs. We want the poll to update all the network information before everything else does its simulation. And how do we know what order it happens in? Potentially, it happens based on its position in the tree. Parents get processed before children do. And in theory, this net object node is going to be in the tree above everything else. I think in theory, this would run first, but we can't actually guarantee that. So what we're going to do is we are going to guarantee it. And we're going to do that by setting our physics. Actually, I think it's inverted. Even though this is physics process, I think what I want is process physics. Yeah, process physics priority. Why is it process physics priority and not physics process priority? I don't know. Anyway, we set this to a number. And the way this works is the higher the number, the slower. So it's sorted numerically. So the thing with priority 1 happens before priority 2 and so on and so forth. And we want to be the first. So what we want to do is, there you go. We want to feed the smallest possible integer in here. This is going to be negative whatever the 32-bit limit is. Is that the 2 billion? Negative 2 billion? Maybe? I don't know. We're feeding it in here because we want to go first. So if we do this, the first thing that happens every physics tick is we sync the multiplayer by running poll, and then the rest of the multiplayer physics happens automatically. So now we're getting this update running. Did I change it to 30 times per second? Yeah, I did. So 30 times per second, we are now processing that. If we run this, nothing should have changed. Oh, wait. Except, no, I'm wrong. Except, right, we're syncing the movement. Well, ish. It's a little hard to see because I can't leave this up here. But this character here, this is the character that belongs to the server. The server is going to move to the corner. And then if I flip back to the client should see the server character moving over there. The client here is not successfully moving. The reason is the client sort of tries to move and then gets flung back to its position from the server because in our code, excuse me, in our code for our like character motor and stuff like that, we're checking to see if we own this object and then we move it. And it's true, the client owns their own copy of the player character, so the move happens. However, this is not currently syncing the network update because the client doesn't have authority over position sync, which we're going to fix. Now, I think what we actually want is a separate script that all right, I'll just do it. Yeah, because we got to do other things with the camera and there's all this sort of stuff. Let's create another node. And I'm just going to call this like the player network node. And honestly, the whole is owner thing could probably be moved here, but let's see. We're going to attach a script, characters, player network. That seems fine. It could also be under networking, but let's just put it here for a second. And what this is going to be responsible for is set up various things that should be on the version of the character that belongs to this local peer. For example, one of the things we want is we would like a camera 2D that is attached to our local player. So the camera stays centered on us. Now, there's a bunch of different ways to do things, right? What I could do is I could add a camera 2D to our player object over here. If I do this, then if I run the game, on the server, this should work fine. As I move around, there you go. There you go. Camera's nicely centered on us. Oh, how lovely. The weird thing is it's also going to be centered on that character on the client. And the reason is both these player characters have a camera 2D. only the first camera 2D that was added to the scene is actually active. You can change which camera is active. I don't love the idea of having multiple camera 2Ds, and some of them are inactive. There's two different options we can do for. One, because I tend to think of in a programmatic way more, I would often think about, I will add a camera 2D to the thing that's supposed to have a camera 2D. The other way of doing it is we'll put the camera 2D on the player character in it for every scene, but then we'll delete it or deactivate it for the ones that aren't supposed to be active. The advantage of the latter is that the camera 2D can exist as part of the player scene, and then we could set up a bunch of stuff in the inspector over here to be just right, and then we could just, we just turn it off for the things that aren't supposed to be active. I think I'll delete it, and instead what I'm going to do, over here in Player Network, I'm going to copy, and the fact that we've got code duplication in here should be a huge heads up that we've done something's not quite right. But I'm going to do this, and actually we're not checking our name, we're checking our parent name. The get parent, yeah, get parent. We'll just assume node 2D dot name. Super. Oh, get parent. Interesting. Does just regular node doesn't have this knowledge? Is that true? If this was a 2D, presumably this would work. What? Oh! Shut up. You know what would help? We included all the syntax we need. Because I put the angle braces in here, my brain was already like, no, you don't have to add parentheses. We've already got things that are parentheses-like. There we go. Okay. There we are. Okay. So we're going to get the name of our parent. This hard coding in the structure, we can all agree is bad, right? Super terrible. And the fact we have two copies of this, horrible. But let's move on for now. Okay. So if not is owner, then we bail because we don't do this shit. Otherwise, what we're going to do is we're going to, on our parent, we're going to add a camera node. So get parent. Okay, I don't know why that, oh, because I typoed and it was trying to do its best. And here I am criticizing it. We're going to add a child. And we're going to set up a new camera 2D. All right. And then, what else is missing? Oh, then I got to change the authority of position sync. So let's do a private multiplayer synchronizer position sync. Why are you not responding to my keyboard inputs? There it is. Export this like that. And really, maybe I should specifically link the parent rather than go look for it programmatically, but we're being fast and sloppy. I'll clean it up before I commit and share the code. We're going to slap that in there. There we go. And so then we're going to say position sync dot authority. Set multiplayer authority to ourselves. Now, this should be quite interesting. Let's say get unique ID. Now, we only get to here if we're the owner. But I suppose this has to be set on everyone. Everyone needs to set multiplayer ID of this thing to the correct owner, which is this. And again, we're duplicating code, so we'll definitely want a, whoops, why did that not copy? So we'll definitely want a, a single source of truth, and this will have to be cleaned up logically. But what should happen here, so the position sync on this player should be told that the thing that has authority over you is the peer that is identified by the name here, has authority over this. And so, and everyone should agree about that. And it's important because this prevents the server. Because what would happen if we only set on ourselves, we as a player would send our position update to the server, and the server would be like, bro, but I'm the authority of this object, so I'm just going to ignore you. And here's the actual position. And then I'm going to get that back from the server and be like, bro, I'm the authority over this thing, so I'm going to ignore your input, and we're just going to desync. Oh, debugging errors. And this is changing from how I did it. Error loading scene must be inside project path. Use import to open the scene and then save it inside the project. What? I'm sorry, what? Everything's saved, right? Yeah, I don't think I did this very well. Ooh, that is a... Interesting, it's debugger 3, but there's just one error. Oh, then session 2 has got its own. Oh, unable to process the pending spawn since it has no network ID. Might happen changing the multiplayer authority during the ready callback. I remember this. Make sure to only change the authority of multiplayer synchronizers during the enter tree combat or callback. I remember this. So, player network, you can't mess with the authority during ready because the timing is off. On enter tree. Enter tree? Well, I mean, I know it says, okay, so it must just be enter tree. There it is. Okay, let's try that again. Well, why didn't I just follow exactly as it was? I'm trying to cut corners to go faster. Unable to process. Oh, this is still happening. But where? I'm assuming it's all this bit. Let me try something. If I just say return. Yeah, unreachable code. It's fine. We might have to set up a signal for on scene ready. Oh, call deferred. Oh, parent node. Oh! Okay. The parent node is still being set up. We need to do this deferred. Call. Oh. Yeah, add child dot call. Oh, I don't know how to do that in C#. Godot C#, add child, call deferred. The function here. We wrap it that way. Call deferred. Instantiate it first. Call deferred causes it to happen between frames. Is what the timing here is for. Cam equals new. And then we do call deferred. On parent. I think this, hold on. Get parent dot call deferred. Yes, there we go. And the function we're calling is node dot method name dot add child. Then we put in the camera like that. Okay. So this will add the camera between frames after the whole tree is set up. It's the sort of thing you don't have to worry about when you're not doing network stuff. Okay. Okay. We still got one error. Out of curiosity though. If I move here, good. That's me. That's the client. That's the server instance. And there it is. Hey, it's working. Animation's not syncing. That's fine. There's a reason for it. Okay, that's working. Now, what's this error that we still got? I'm changing authority, but where? Net node. I am changing authority. Maybe I should do this as a call deferred as well. It's interesting that it still worked. Is there any chance that I don't do this everywhere and I just do it here? That doesn't sound right. That doesn't sound right at all. Yeah, I'm getting a million errors. Yeah, okay. It's got to be here. You can call the new camera and call deferred if you want to. Don't need the intermediate variable. Yes, that's true. That's true. I could just go new camera. That is absolutely right. Oops. I guess the reason we might want to do it here is if we want to set some properties to camera. But yeah, so it's got to be this. Okay. Position sync dot call deferred. And then we do node dot method name dot set multiplayer authority. And then we pass this. Oops. No errors. Okay. So the reason that the animation isn't syncing is because the animation is trying to read the velocity. And on the non-local, like on the network copy of the player, the velocity never changes. What we'd have to do for that is over in our player character in position sync, what we want to do is add a property sync velocity. Oh, sorry. So it's on player character, sure. Velocity, except it's not there. The reason is velocity is not an exported variable, so it doesn't show up as something that we can sync. And for all sorts of different reasons, we probably want to sync that. For now, it's literally just for the animation, but later on, for predictive movement and things like that, we might want access to that. So what we're going to do, over in character motor, we're going to do a little public vector2 synced velocity, where we're doing get velocity set velocity equals value. Did I get that syntax right? We're just wrapping it in a little property here. Compile, and now I should be able to add property sync player character. Oh. And export. Yeah, there you go, sync velocity. And you don't have to sync the whole velocity. You could just sync the X or the Y. I mean, we're going to sync the whole thing. Okay, there we go, on spawn. Well, technically on spawn, that should be not required because it should spawn with a velocity of 0, but sure. Hey, look, the animation's synced now because we're sending the velocity over the network. Whee! Now, the animation might be a little choppy on the server because it's only updating the position 30 times per second. But this is where we do a little bit of interpolation and things like that to smooth out the motion a little bit. But there we go. Oh, it works. Okay, that brings us to the end of my plan for today. Just went an hour and a half more. Wow, I knew we were going to go over. I was hoping we wouldn't go quite this over. But we've got this. probably, with a fully scripted tutorial and a little bit of editing of some of the ums and ahs and some of the delays, this could probably have been done in, I mean, I think each one of these would be an episode. Some of them might be 30 to 40 minutes. Some of them would probably be like 15 minutes, but there's some value in the live stuff. Maybe I'll do an edited version of it. I actually recorded this twice, in fact, or 3 times. Twice I uploaded it to the Quilly Teen Creates channel, but I didn't make them live. Because I'm like, I think I can do better. I'm not sure that this was better, but it's sure as hell fun to do it interactively. Even though I cut a few corners over here, as opposed to the clean version I've got there. Again, what I'll probably do is before I go and publish this video and get the GitHub link, is I will clean up the code and do some of the things a little bit right. Some of the little hacks and shortcuts, especially with the ownership. We got to go and put it there. It probably belongs in like the player network script. I think the ownership kind of concept makes a lot of sense to live here. It doesn't make sense in character motor, so we'll probably just rip that out and have people read this or something like that. We will see. That's something you could add to my 400 level networking lecture. Oh, cool. Developer, I was hoping it wouldn't go this much over buffer. I know I baked in some buffer. Well, that's the reason if someone asked you how long it's going to take, if someone had asked me how long it would take to do this, I'd say, give me 3 or 4 days. You know, maybe it was only 3.5 hours of programming and conversation, but I'd sure as hell give them the Scotty estimate for sure. You got to pad your estimates. And even then, the manager should add extra padding on top of that. The problem with programming is it's always hard to know. Someone will come to you with a problem, and it's like, how long will it take? And sometimes the answer is, I'm not sure if it's going to take me 10 minutes or 10 hours. Until I start working the code, until I've done the job, I won't know. It's sometimes really weird like that. Do I do agile? Just wanted to know your space game video made me take the plunge Great Mountain game and Godot. Nice. And yeah, again, like with my space game, which does have some multiplayer in it, but it's all hand-rolled networking, and it works in a very different way from this because of the nature of the data. It's much more similar to, like, because of my web development background, it feels a lot more similar to that kind of aspect where like the client is like such a thin layer over the server. And is like, I literally like subscribe to certain data and then unsubscribe from it depending on the context. Like when I open the inventory screen, then it subscribes to the inventory from the server. Well, an inventory might be a bad example. I might always be subscribed to that. But like when I dock to a planet, it's like, okay, I would like to subscribe to the updates about Earth right now. And then when I undock, I drop the subscription because I don't need to know that Earth data anymore because it would just plunge up the bandwidth. But that's because the imagination of that's going to be a huge world, and the player only ever needs to see a limited view of it in any given time. So very different kind of multiplayer requirements over there, or multiplayer sync. So yeah, it's a little sloppy, but it's working. So always good for that first version. And then you just clean it up, and then what happens is you iterate. Like, here's the question: where would we put our character's health and armor and attack speed and the fact that they're wielding a +3 greatsword or something? Where does that information live? Well, what probably happens is, so we have some sort of character stats that doesn't even have to be in this tree, right? We could have some code that syncs it, but it's reading it from a pure C# library somewhere, something that's accessing, I don't know, maybe you got a SQLite database on the back end, or this or this or this, or it could be a resource that's in here. Or what we could do, and might be the simplest, is we could have a node called like character stats, which has a script on it called character stats. And all it does, well, not all it does, but one of the many things it could do would be something like, public int hit points equals 100. I mean, obviously you'd want max hit points and different things and yada, yada, yada. Just for the sake of whatever. And then we put an export on that. And then we sync it. And what we do at this point is we add another multiplayer sync. And the reason we'd have a different one is because, so this would be like the stat sync, is because the position sync right now, with the way we're doing it, has authority. It's local to the owning player. But the stat sync would probably be from the server. The server manages the stats and informs everyone about it. And then stat sync would just be like, okay, I'm just going to sync from character stats. I'm going to sync hit points. And this would be a good example of only sync on change. Because while a player is actively regenerating health, yes, it's going to update fairly often, although probably not every frame. Maybe you regenerate 1 hit point every second. And then, and a lot of times you're sitting at max HP, so these updates don't send at all. So you just send on change, and you do want that to be reliable. You want to know that it got there. The thing about the position, right, because with always is unreliable, you could send a packet that doesn't arrive at the other end, or even arrives out of order. But the thing is, there's going to be another packet in 1/30th of a second, in 33 milliseconds, that's going to correct it, and it's going to be self-correcting all the time. So that's going to be okay. But for like the health and things like that, you'd want it different. So if we do this, having done this, if anything goes into character stats and changes the hit points, StatSync is going to make sure that gets sent out to everyone. And then it becomes also kind of interesting of like, okay, do all of the stats of all the characters have to be sent to everyone? Like, does Alice need to know that I have 27% fire resistance? No, the server needs to know. And arguably, I only need to know so that when I open my character sheet, it shows up in there. My game engine isn't going to be, like my local game engine isn't going to be doing anything with fire resistance. It's not going to be calculating how much damage I take in. I only need to know so I can see it on my character sheet. Alice doesn't need to know at all. Alice does need to know that my +3 greatsword shines with a bluish light. That's important. So then it's like, okay, so when we're syncing like the equipment, Alice doesn't need to know the stats of my greatsword. Alice needs to know what the image or model, if we're talking about 3D, is and what the texture might be and if there's a glow effect on it. That's what Alice needs to know about my greatsword. So those are kind of interesting things. Anyway, we're going to wrap it up. I'm going to save my voice. Saturday, I don't think there's a stream. Saturday, I will almost certainly be away visiting my parents. So you can just assume there's no Saturday stream. Next Monday, we'll be back. And I don't know what we'll be doing. I still want to finish the Fangs of Astrakhan expansion for Grim Dawn, so I might do that, but I do want to take some time to make sure to chooch through a couple of the expansions before I come back to that. We'll see. Or Monday might end up being auction not included since we're not going to be running it this Saturday. We'll see how that goes. We'll see. Is Godot only UDP? I think the Godot, like built-in networking is UDP. But of course, there's nothing stopping you from, you can roll your own networking code, which again, in my space game, it's basically a pure C# game that is only using Godot to show the visuals on screen and to like process mouse clicks. Everything else is happening behind the scenes. And that does use TCP because I'm only doing network updates once per second because I'm copying, well, not copying, it's very different. I wish I was copying, but EVE Online. EVE Online's networking model is basically 1 update per second. And that's what I started with. Cause I'm like, that seems like a good idea for a game that's kind of slower pace. It's working out brilliantly. So I'm using TCP so I don't have to worry about lost packets or anything because I'm not sending as much traffic. So the overhead doesn't matter, but it is imperative that it lands and doesn't miss an update. So I use it for there, but yeah. How to stream on Linux? So I'm not streaming on Linux. I'm running Linux inside of a VMware. So it's still I'm just on my Windows machine, just capturing VMware over here. But yeah, it's smooth. I originally set this up with VirtualBox, but VirtualBox had some like real problematic performance issues, which was really weird. So anyway, VMware is what I picked up instead to get this sorted, and yeah, running pretty swell. All right, folks, thank you so much for coming out. We're gonna shut down the stream here, and I'll see you next Monday for History Game. Bye-bye.